Good morning, everyone, and welcome to the second day of the International Conference of Suwanu Europe project. Suwanu Europe is a thematic network funded by the European Commission within the Horizon 2020 program. For those of you who were not yesterday here with us, my name is Rafael Casielles. I'm from Bioazul, and I am the project coordinator of Suwanu Europe. Yesterday, we had a very interesting and productive session. It really exceeded our expectations. We saw water reuse from different angles and went from global to national and regional approaches. There were many inspiring messages. I would like to rescue a couple of them that I think are remarkable and they're worth to be emphasized today. First of all, the untapped potential of reclaimed water. According to the European Union, more than 40,000 cubic hectometers of wastewater are treated every year, but out of it, only 964 cubic hectometers are finally reused. This is around 2.5%, so it's a very little amount, and there is still a long way ahead. Secondly, water reuse is linked to water scarcity, but not only. It's also linked to the scarce availability of nutrients and other resources. For instance, phosphate rock is on the list of critical raw materials of the European Union. Note that there are only 20 raw materials identified as critical, and one of them is the phosphate we use to fertilize our crops and produce food. And Europe has very limited resources of phosphate and is largely dependent on imports. So we must take advantage of every resource included in our water. Finally, sustainability and resource efficiency must be at the center of the European recovery plans. And water reuse is crucial here to create new jobs and to contribute to a more sustainable and water-smart society. There is also a very promising field of research on the recovery of chemicals, energy, and other valuable products. Also, the reuse of sludge has a strong potential. Some of these innovations will be tackled today in the elevator pitch session. Our objective in Suwanu Europe is that knowledge triggers the use of reclaimed water in all over Europe and beyond. As I presented yesterday, we have produced in our project an extensive catalog of capacity-building materials. All this work will not have been possible without the contribution and support of our 20 partners. We have a great consortium of partners coming from 10 countries. I want to take the opportunity today for a short name and for a short mention, so I can name the consortium partners. So if I have a minute, I would like just to name them because they have contributed very widely to our project. These partners are Bioazul, as coordinator, FENACORE, ACERSA, University of Córdoba, TTZ Bremerhaven, Braunschweig region, ANEF, Aristotle University of Thessaloniki, Agricultural University of Plovdiv, Confagricultura, University of Torino, Canale Emiliano Romagnolo, Mecorot, Consulae, which is hosting the conference today and yesterday, FENAREC, University of Cyprus, Agricultural Chamber of Cyprus, Ecophilae, SECU, and Profstation. Thank you all for your commitment and dedication in the project. Today, I'm also honored to have with me Angela Magno from Bioazul and Rui Almeida as representative of Consulae in Portugal. Hello, Angela, how are you today? Yesterday we had a great conference, wasn't it?
Yeah, it is. Thank you, Rafa. Good morning, everyone. Again, thanks to all of you for joining us today. Yes, I feel very proud about our first conference day. I think that yesterday was a very interesting day with, we have our keynotes. Marie Raffin talk about water policies, And also we have the keynote on socioeconomic aspect by Gonzalo de la Cámara. Both of them with a long experience, and they brought us important aspects to take into account for the future of water reclamation. Also, Rafa, you gave us a nice overview about our project Suwanu Europe and its main outputs. As you mentioned yesterday, we have available for all of you in our website, and we'll share it with you this output. Also, we were able to know better the work done by our 8 target regions in our cross session. And I want to thank again all the partners for the inspiring work that we enjoyed yesterday in our dynamic session. And we finished the day with the experience on water reuse from Cyprus and Israel. Thanks again to Poppy and Diego. So for those of you who could not be connected yesterday, just remember that the session were being recorded, and we will share them on our social media. Indeed, our followers are using the hashtag Suwanu EU conference. Please use it, comment our event, and I invite you to make this community better and more connected. Finally, I cannot forget to remind you that we'll be happy if you participate with us through our chat, leaving your comments and questions. Good morning, Rui.
Hello, Angela. Hello, Rafa. Once more, thank you so much. As you just said, I guess that's with our smiles, you can see that yesterday went quite well.
Yeah.
Went quite well. Yeah. So good morning to all of you. And today it will be even better, I would say. So just to remind all the participants that we had around 500 registrations, and we had an average of more than 200 participants yesterday, so which is great. It's great. And we had, as you just said, Angela,
nice.
Very good feedbacks, not only about the organization of the conference, but also about the quality of the speakers and their presentations. And so my congratulations to all of them, because as we know, it's a complex process when we are online, because they had to test. There were a lot of tests. They had to be available for that, to test the sounds, to test the cameras, to test the presentations. So, and I guess this shows the commitment of the speakers and also of our partners in the parallel sessions. The commitments with our projects, but also with this thematic. So a big thank to all of them. And let's see how it goes today. So starting today's agenda, you can expect again a very productive and interesting and dynamic morning. We'll have one keynote presentation focused on water reuse opportunities in Water for All Partnership and Horizon Europe. And this will be with Panagiotis Balabanis. It will be an honor to have him. Then we will have the elevator pitch session with the authors of the selected abstracts from our call for abstracts and posters. Just to remind, we received more than 20 posters and abstracts. And we will have today this elevator pitch. We'll have 11 of them. But the others are, again, available in our platform. So in your screen, in your left side, you can see an icon that says PDF. Please go there, check the abstracts and interact, because you have there, you can rate them, and the authors are anxious to see the rating of their own project. So please go there. So we'll have quite interesting projects done in this thematic, and it will be a very interesting session, I guess. It will be only 5 minutes each, and let's see how it goes. Then we'll have our short break, and after that we will continue with Marta Carvalho. She's coming from Águas de Portugal, so she's playing at home. She's coming from Portugal. And for the second keynote speaker today, we will give us a presentation focused on technology and innovation in water reuse. So Marta will share her thoughts on that. Also during this morning, we'll have a roundtable with partner entities of the project and other experts. It will be Rafa, you will be the moderator.
Yes.
How is it going to be, Rafa?
Okay, well, the roundtable will be a discussion, an open discussion about the challenges of the new European regulation, the regulation on minimum requirements for water reuse in agriculture that was very clearly presented yesterday by Marie Refan.
Yeah.
And but this regulation, it was approved last year in June 2020, and it will be mandatory in 3 years. We have 3 years of margin to adapt ourselves to the member states, to be adapted to this new scenario. And it's going to be a challenge because this regulation implies more stringent requirements in terms of water quality. Also, we have to do risk assessment management plans. So there is a new framework for water reuse. And I will say that we are not really adapted yet. So we have to change many things. We have to change technology to have better quality effluents for irrigation in order to comply with the quality standards. But there are also other things to adapt. We need to adapt administrative procedures. We need to adapt probably the training, the different actors in the chain. So the idea of this roundtable will be to discuss what are best strategies, how we have to deal with this new scenario. Okay.
And Rafa, I realized that yesterday there were 1 or 2 questions in our chats that we hadn't the chance to present to the keynote speakers. So I'll try to save 1 or 2 of those also for the roundtable. If you give me 30 seconds, let's see how it goes. If not, we will come back to the after the conference. We will answer to those questions for sure. So the theme of the roundtable will be challenges and strategies in water reuse in agriculture and lessons learned in Suwanu Europe in the context of the new EU regulation. And last but not least, we will finalize our conference with a keynote presentation moderated by Andrea Rubini from Water Europe and Antonia Lorenzo from Bioazul partner and leader of our consortium, from networking of the Water Europe platform. So we are counting on all of you to join us during today, as we believe that only with your support we can make a difference. And again, as the film says, and we like to say, every drop counts in Suwanu Europe. So Angela, now I pass to you. I guess you'll present the keynote presentation?
Yeah, of course. Thanks, Rui, because now we have the honor that introduce the first keynote for today. I have the pleasure to introduce Mr. Panagiotis Balabanis. He holds a diploma from the Agricultural University of Athens, Greece, a master's degree and a doctorate in mechanics of mass and energy exchange from the University G. Fournier de Grenoble de Fers in France. Before joining the European Commission, he worked as a research associate at the Agricultural University of Athens. But since 1990, Panagiotis Balabanis is working at DG Research and Innovation in the European Commission. He's actually head of the sector water in the Circular Economy and Bio-Based System Unit. In this context, he's dealing with issues related to water, resource efficiency, and circular economy, with a view of supporting the transition to a healthy planet, which is climate neutral by 2050. And operating within safe planetary boundaries. During those years, Mr. Panagiotis Balabanis has been involved in the definition and implementation of several research programs in the field of water, environment, and sustainable development. Today, Mr. Balabanis will give us a presentation on water reuse opportunity in Water for All partnership and the Horizon Europe. So, hello, Mr. Balabanis. Thanks to be here with us. The stage is yours, and it's an honor have you here.
Hello. Good morning to everybody. Can you hear me?
Yes, we hear you
perfectly.
Okay, thank you very much. Thank you very much for this kind also introduction. A pleasure also to be with you today. This is, of course, a very, very important subject. I followed yesterday, the morning, the different keynote presentations, and who have demonstrated already, let's say, the importance of water use in this context. And of course, this is very strengthening, the importance, the challenges that we have, we have to change the way that we manage also water. The challenges are complex, and of course, the water use also prepares and presents, a lot of new opportunities, and which have been also highlighted. I will try to, in my presentation, before also presenting a bit more, giving the an overview of what is going on in Horizon Europe in the area of the water, and then also focus more on the water use opportunities. I think I would like also to mention a bit earlier, to give an overview of what has been done also before in the water area within the context of framework programs. And I will, as you can see here, I'm just focusing on the last, the previous framework program, Horizon 2020, when, as you can see, water has been an important component. It has been also supported through different also pillars of the Horizon program. It has been foreseen and supported through, it was mainstream, we can say, within the different pillars, but of course it was also a key component on the environmental, climate related thematic priority, but also in the food related, also agriculture related challenge, challenge 2 and societal challenge 2 and societal challenge 5. Here there were the main activities in this, and here you can see, the focus. So we started not only to look on the knowledge, to generate also consolidate also the knowledge, but we have tried also to support also the policy needs, and I will give also a concrete example, because, as I said, we have also to try also to address some of the barriers, some eventually, regulatory or financial or also barriers, which also affects the uptake of different also technologies. Going a bit, more on the water reuse, on the water and circular economy dimension. This, as I said, has been also in this big number of projects which have been funded. Here you can see the different also research areas, issues which have been also addressed within in the context of water and circular economy. And here you can also see reference to some ongoing projects or recently finalized in related also to the water use. And as you can see, we're trying also to demonstrate different projects on water use. We have also to address also, in particular, also in the agriculture area. I take, for instance, the example, as you can see here, the Idrusa, which is an ongoing project, and this is a kind of a project which tries also to demonstrate the implementation of low-cost, nature-based and other engineered solutions for the recovery of non-conventional water resources, wastewater, seawater, rainwater, also vapor water, and this also to be used also in agriculture, but also for domestic use. And I think this is also a particular project which is focused also on Mediterranean, particularly the Mediterranean islands, in particular, which are also are very scarce areas, and of course there water use is also opens a lot of opportunities. As I mentioned before, and I think I would like also to mention a bit and to stay a few minutes to explain about this innovation deal, because innovation deal has been a kind of a pilot activity which has been also foreseen in the circular economy action plan, the first action plan when it was also adopted by the Commission, and it was foreseen as a way where, for instance, innovators which can consider that there are also some financial or some legal, mainly legal regulatory barriers which can affect, their innovation and the uptake of their innovation. It gives an opportunity these people to come together with also the end users, with also the authorities and with policymakers also to discuss issues. And in this context, between the two pilots, one, it was really focused on this technology. It was about the water use, using also trying to explore the potential regulatory barriers for the application of innovative anaerobic membrane technology for the treatment of urban wastewater, where the treated water there is intended also to be reused for irrigation agricultural lands. And this is a technology who has also many economic and environmental benefits. But the problem is that this technology also maintains also the nutrients in the treated water, and then therefore this water can be also used, also combined also for irrigation and fertilization. And the evidence which has been proposed also by the consortium demonstrated that there is a kind of a regulatory barrier regarding also the application of this technology. And this regulatory barrier was mainly stems from the strict requirement that we have in the Urban Wastewater Treatment Directive for nutrients removals from all wastewater in nutrient sensitive areas, including also the water also which intended also for irrigation. And of course, besides these barriers, this consortium also claimed that there are other barriers, for instance, the lack of definition of the term of discharge in water reuse, water pricing, or something like that. So it was an opportunity where really these barriers have been also discussed within the consortium and also policymakers. And I think the also Commission Service analyzes also these suggestions, and also these some proposals have been made on following up of this. And for instance, we have proposed that the outcomes of and the arguments of these innovation deals are now considered also in the ongoing evaluation, for instance, for the Urban Wastewater Treatment Directive, also in the context also of nitrite directives, which will be also addressed in the future. But what is also important is that also the Commission also proposed also, and this is also a message that I would like to make here, because the main problem was the application of this technology in sensitive nutrient areas. So there, the suggestion was also to try also to also to apply also this, to implement this technology outside, for instance, the sensitive areas. So through demonstration, through projects, when we can also make also together also the farmers and also the water operators, because there are a lot of potential. So this information is already available. The outcomes of this work has been already published in the dedicated website. So I would encourage you also to look this more carefully. Let me now go very briefly to Horizon Europe. I would not have to also to stress that Horizon Europe is really a kind of an ambitious program, which has been also proposed by the Commission. It has been already proposed in 2018 with some ambitious also budget from the Commission side, which also, of course, at the end, as you will see, still the final also decision keeps also this ambition also in terms of budget. What I have to mention is that of course, the Horizon Europe is continuing, is not something completely new, is based on the Horizon 2020, and here you can already identify, for instance, the three, let's say, pillar structure approach that we had already in Horizon 2020, and as you can see, pillar 2 is the equivalent, of the societal challenges that we have in Horizon 2020. What is important also to strengthen is that Horizon Europe is not only foreseen as a kind of an instrument also to boost also the scientific and economic impact, but I think what is also important to stress is that it is also seen as a way also to support also the political also priorities. And this is very, very important because for the first time also the framework program is clearly also linked to the political priorities, and we know that two of the political priorities of the European Commission is also to accelerate this digital transformation, the green and digital also transformation. So supporting, also contributing to the European Green Deal is one of the objectives of also Europe, and this, as you can see, is already also reflected also in the structure. As I said, the budget which is already foreseen for Horizon Europe is still, I think, considerable. As I said, the Commission proposed an initial 100 billion for Horizon Europe, and last year the European Council and the Parliament also agreed with a budget 95.5 billion, which also includes also about 5.4 billion, which comes also from the Next Generation Europe, which is the program also to support also the recovery of the European economy from the pandemic also crisis. And I think this is important to strengthen that this will make also Horizon Europe one of the biggest, let's say, framework programs. This slide, as you can see here, shows a bit the different clusters which are in the pillar 2. You see, the 6 clusters. And why I present this is that, of course, water is also relevant to several of these areas. It is also important also in the health, intervention areas dealing with the environment and health issues. and also with infectious diseases. So there, water is also is an important element. Also in the cluster, which is more the industrial, let's say, a cluster, the cluster digital industry and space. Here you can see we have also the circular also solutions. So this is also to promote the industrial symbiosis, and of course there water reuse is also an important component. So of course I cannot go in the details on all these issues. I will more focus on cluster 6, which is about the food economy, environmental dimensions and agriculture, because I think this is one of the key classes where water, and particularly also water reuse, will be also very important. As you can see here in this cluster, which, as I said, is the cluster which will also look on this transition to sustainable and circular management of natural resources, addressing the whole dimension, from land to sea, and trying also to balance also the sustainable development with well-being, and including also issues about water security, food security, but also nutrition, also security. So these are key elements of these clusters, and these are, as you can see, are the 6 what we call the expected impacts of this cluster 6. And these expected impacts are very important, because what is important is that, as I said, this is a way, for instance, to link the also the work programs with the overall policy frame and the policy also priorities that I mentioned. And I think this is important because this has been, for the first time, has been identified in the context of I would say a kind of strategic planning, where an exercise, an intervention logic has been used also to try also to link also the Commission's also the policy also priorities I mentioned, the European Green Deal, the digital agenda, also with also the different intervention areas and the different also the cluster. And this strategic program is and plan has been in particular also focused for this pillar 2, the different also clusters. And as I said, this is a kind of interface between also the research areas, the intervention areas also, and the policy priorities. What is important is also to and you can see here, this is also a good demonstration how also the different expected impacts of cluster 6 are also very well linked to the European Green Deal. Here I highlighted, in a circle, the parts which are of the Green Deal, which corresponds to the different expected impacts. So as you can see, we have here about, the farm to fork is about biodiversity, is about also the circular economy, the climate neutrality. So these are reflected in the expected impacts of the cluster. Going a bit more on the details on how, for instance, water is included. Here you can see that the water will continue also to be addressed in the different also expected impacts. And here you can see a kind what we call, the type of a destination, which will be a kind of a group of related also issues, which are also linked, these destinations, to the expected impacts that I mentioned. So you can see here the related also impacts to ensure, for instance, the biodiversity and ecosystem services. So here we have issues related with freshwater ecosystem, also restorations. We would also try also to address also the linkages also between the biodiversity, water, food, and health in the context of the circular of the climate change. We will also address also the issue of healthy and friendly also food systems. So issues regarding also to the nutrients, to the recovery, natural-based solutions for nutrient management are also relevant, and there, of course, water reuse could be also relevant. In the destination related to the circular economy, we will have also several issues. For the time being, the emphasis is not completely on water reuse in the first 2 years, because as you have already seen, there are still several ongoing Horizon 2020 projects. So it will be nice to see also the outcome of this project. So we will most probably have also more important topics also in the remaining also work programs. But for instance, in the area also on climate and water, when we are looking also about water allocation systems, so of course the water reuse dimension in these water allocations at the river basin scale, for instance, are also areas that have so elements of water reuse will be also important. And of course, as you can see here, a very strong component in the first work program will be also related to the pollution issues. So there is about also groundwater contaminants, about diffuse pollution in urban areas. So there will be a lot of water-related issues. As I said, less focus on water reuse, but water reuse elements could be also included. And least but not last in the area, topics also dealing with water governance. So and then of course issues related to the application of water reuse, water scarce areas not only would be very important. So this is areas where also water reuse would be also relevant. What is important is that, of course, beyond the traditional also calls, some other instruments have been also highlighted in the in Horizon Europe, and one of them is the European partnerships. And this European partnerships is a way, is a mechanism also to put together the different also activities of the member states, together also with the commissions, in order also to close also the synergies between also these European and regional problems, but also to trying also to address also the global challenges, and trying also to achieve also the impacts of Horizon Europe. And in Cluster 6, in the first work program, you can see here we have 3 water-related partnerships. Of course, the water for all, this water security for the planet, is the main one. But I think the 2 others dealing with the blue economy and biodiversity are also related. And water for all and all the partnerships, they have also to address also synergies, and to have also to strengthen also the synergies in the different these concepts. If I go a bit more details on the water for all partnership, excuse me, coming back to this slides. So this is water for all is, as I said, is a partnership which is built on the on the previous water GPI, but also brings together also the other public-private partnerships, like for instance the Water Europe was the European technology platform, but also elements of the European Innovation Partnership on Water are also included in this partnership. So this is a kind of a wider group of the water GPI, which also will have also the opportunity also to implement a kind of a larger range of actions, which go of academic and applied research to innovative solutions, but also to address also the issue of the transfer to this innovation also to the policymakers, trying also to address also the science policy interface, and also to make a kind of to address also issues which cannot be addressed with a limited duration of calls and project which is funded within water within the calls, the normal calls of the work programs. And what is also important is that, of course, the water for all will try also to address also this global water emergency crisis related also to the water scarcity, but also issues related also to the pollution, and particularly also the issue of emerging contaminants like the micropollutants, but also address also the extreme meteorological events, the biodiversity decline, but also the other challenges which prevent also the achievements also of water-related objectives. Here you can see a bit the type of implementation, actions which are highlighted there. So, as I said, very focused on demonstration activities, on transfer to information to the policy, and also an important also dimension is also to the international dimension. We would like also to use also an instrument also to address also the other, to attract also more international cooperation and structure better the policy dialogue with other international countries. The Water for All has already developed, a strategic research and innovation agenda. This is here you can see the main thematic also priorities of this area. We have main 5, let's say, main thematic also priorities. The first 5, and there are 2 ones, the governance and the international, which are more cross-cutting. And what is also important is that here you can see what we call the drivers and the enablers. The drivers also refers to the factors that they may trigger also the changes in the strategic priorities, and there you can recognize the climate change, the biodiversity decline, food security, for instance, the global also trends, the migration issues, and then the enablers, which are the factors we can facilitate also these activities and facilitate also the achievement of the different also objectives. And in the first topic area, which is related to the area of circular economy, and we can see, for instance, some of the areas of the water reuse elements which have been also proposed to be addressed. I would like also to strengthen, in particular, also the particular emphasis which has been highlighted also yesterday in the keynote presentations about also the different socioeconomic aspects, about the governance, the behavioral changes, the social acceptance, which is needed also to in order also to strengthen also the reuse. So these are important elements. Also the long-term implications of water reuse, the impacts that they may have also on the different environmental compartments. It would be important to assess also this issue. And then I would like also just to also mention to you and finish also my presentation, also highlighting also another also novelty in Horizon Europe, which is about the mission, and the missions are seen as a dedicated also actions which can also trying also to develop, also to produce also what we call some European public goods, on a grand scale, and help also to bring also European research and innovation also closer to the people, demonstrates also concrete solutions which can also provide also to face up to major societal challenges, and also to instill also some confidence also to the green transition. And the Commission also identified 5 European missions in the first work program, and 3 of them which are related to the climate change adaptation, to the soil health and food, and the ocean, seas, inland water missions, of course, are water related. And these missions will also develop, in addition, also dedicated actions to be also foreseen in the next work program, and I think it will be important also to look also the possibilities also for water reuse also in this context, and I'm confident that there will be also this opportunity. So with that, I would like to thank you for your attention, and I will be happy in case that there are some questions to reply. Thank you very much.
Thank you very much, Mr. Balabanis. It's really experienced and interesting your speak. And only just a quick question, because we don't have much time. But Water for All will have its own work program with their own calls, or will it be just part of the Horizon Europe and the rest of the topics?
Yes, thank you very much. Very good question. This will be, it will have its own, let's say, calls, dedicated calls. Actually, the Water for All, there is a dedicated topic in the work program, which will allow us, to formalize this partnership, and this is foreseen in the work program 21. So this is a call which is dedicated to the consortium. So this will be a unique also consortium, because this should be a kind of inclusive also proposal. And this let's say grant is going to be adopted and will be more probably also signed at the end of the year, the beginning of the next year. So from next year on, the Water for All, it will open its different activities. We'll have also activities for joint calls, but will be also other additional activities beyond also the joint calls, and there will be individual calls which will be also published by this Water for All partnerships, and will be of course equally also diffused and in the Commission's also web portal, but also under the Water for All. Thank you.
Oh, okay. So I write it down. I think that we present any kind of proposal for that. So thank you very much. It was a pleasure.
Yeah.
Thank you also.
Yeah. Thanks a lot. Thanks a lot.
So maybe we start with our elevator pitch.
Oh yes. It's the moment for the authors to present their own abstracts. So first we want to thank everyone who participated in our call for abstracts and posters. Now we'll have the elevator pitch session, where the 11 authors of the selected abstracts and posters will present their own work. However, as I said before, all the abstracts and posters submitted are available in the virtual gallery in our platform. All of you can check the abstracts and the posters and contact the authors directly. So, the first presentation will be with Serena Radini from the Università Politecnica delle Marche in Italy. Serena, can you hear us?
Hello, everybody.
Yes, I can see you already. How do you feel today, Serena?
Fine, thanks.
Fine? Okay. So the floor is yours. Please keep the 5 minutes, okay? I guess you have a green light and the red light, so this will tell you the 5 minutes that you have for your presentation, okay?
Okay.
Thank you so much.
Thanks a lot. I would like to share. I have to share my screen, or okay. Today I present a work that focuses on strategies and tools to support risk assessment and management on a demo case of water reuse for agriculture irrigation in an integrated approach. So first of all, we will focus on the development of integrated approach for the global wastewater cycle. Then it was applied a risk matrix to define all the hazardous events that came out. From those outcomes, a quantitative microbial risk analysis was performed, and its results were used and considered in risk management. The integrated approach consists in the identification of the global system from its catchment to wastewater treatment and reuse, and to its final use in agriculture. Each one of them was schematized into critical nodes. For each one of these nodes, all the possible hazardous events were defined and characterized, attributing scores to the likelihood and the severity of their outcomes. Then existing control measures applied to reduce the probability of those occurrences were considered, and integrative control measures were also suggested. From the outcomes of the risk matrix, it was found that a specific focus was important for microbial risk, so a quantitative microbial risk analysis was performed. Since effluent pathogens concentrations were available, we defined the influent pathogens concentration, considering the pathogen reduction of each treatment unit and the ratio between the indicators of E. coli with the referent pathogens of rotavirus, cryptosporidium, and campylobacter. We considered also all the irrigation method and as well as the exposure barriers that could be applied in order to define different exposure scenarios for farmers, local community, and consumers. With those response models, it was calculated the probability of infection and illness, and then was calculated the risk, which was compared with the human target provided by WHO and EPA. QMRA was calculated with the support of Monte Carlo simulation, and each parameter was described using distribution and values provided by literature and international guidelines. While for E. coli, since measured data were available, a specific analysis was conducted. 2 different periods were distinguished before and after water use, and the probability distribution was defined and the Weibull distribution was found to be adapted. The results, in worst scenario cases where any preventer measures were applied, discovered that only rotavirus for consumer was beyond the health target for WHO, while considering only the preventive measure of washing the produce, the risk could be reduced of 1 order of magnitude. So in the conclusions, QMRA is a standardized approach where literature values and tools are available, and we can use Monte Carlo simulation to reduce uncertainties. On the other side, we should need measured values in order to verify the security of the system and the reliability of the data. Thank you.
Great.
Thank you, Serena. Thank you so much, and congratulations for your work and all your team, and thank you so much also to keep the 5 minutes. It was perfect, and good luck for the next steps of your work. So now we proceed with Maria Remedios from La Mayor Institute, Spain. Maria, can you hear us?
Good morning. Good morning.
Hello, how are you?
Hello, can you hear me?
Perfectly. So
Okay,
it's a pleasure
thank you.
to have you here. Don't forget, you have only 5 minutes, okay?
Okay, okay.
Let's start. Good luck.
Okay. Well, good morning, everyone. First, I want to thank the organizers of Suwanu Europe for giving me the opportunity to show you some of the results we obtained in Richwater project. I don't know how to move to the next slide. Okay, thank you. Well, it is well known that the irrigation with reclaimed municipal wastewater is a promising option to reduce the pressure of freshwater sources in the Mediterranean semi-arid regions. It's for this reason that we joined the Richwater project to evaluate the convenience of reclaimed water to be used for irrigation of horticultural crops. The next, please. In this project, we compare the chemical composition of the water used by the farmers of the municipality of Algarrobo with the chemical composition of the water regenerated by means of a membrane system designed by Bioazul. Taking into account the concentration of salt in these two types of water, we elaborated the irrigation solution for 3 very important crops in our region, which are avocado, mango, and tomato. In this slide, I show you the fertigation equipment in the before slide that we use it for distribute the irrigation in the different sectors. This table shows you the parameters that we analyzed and the scheduled samples that we carry out during the period of 2 years. We name the local water as LW and reclaimed water as RW. Next, please. Okay. The electrical conductivity recorded was higher in the reclaimed water than in the conventional water, but these values were in the reclaimed water, represented by the violet line, always below the maximum values established by the Spanish regulation in force during the time the project was carried out, and that was 3,000 microsiemens meter. Next, please. Regarding the content of essential nutrients for a good plant development, such as nitrate, phosphorus, or potassium, we recorded a wide fluctuation over time in in the reclaimed water, which always presented value much higher than those recorded in the conventional water, represented here by the blue line. Next, please. No, the before. Okay, the former. We also recorded in the reclaimed water a higher content of calcium, sulfates, and magnesium versus the content of these elements in the conventional water. Then, the next, please. We wanted to evaluate whether the nutrients in the reclaimed water presented any difficulties for them to be absorbed by plants, and therefore we analyzed the sap of plants irrigated with the two types of water. From now on, in my presentation, I only will show data recorded in tomato crop. The next one, please. For this crop, we found that in the plants with irrigation prepared with reclaimed water, the macronutrient content was much higher than the content recorded in the sap of plants irrigated with conventional water. But no significant differences were found in key processes of plant physiology like photosynthesis, stomatal conductance, leaf water potential, which suggest that the greater concentration of nutrient inside the plants irrigated with reclaimed water were not inducing any toxic effect. Next one, please. Mineral content of fruits were similar regardless the type of water used for irrigation. Neither differences were found in the content of macronutrients or heavy metals. As expected, no differences in water content of fruits were recorded, which represent about 95% of their weight. And consequently, no differences were found on total yields. Next, please. The main conclusion that we can draw from these studies are: recorded data show no differences in net photosynthesis and transpiration rates, neither in leaf water potential as a result of irrigation with conventional water or reclaimed water. No differences were found in major mineral and heavy metals content of fruits from plants irrigated with conventional water or reclaimed water. Content of heavy metals in the irrigation water and fruits were below the threshold limit stated by the Authority of European Food Security. Considering that reclaiming water contains high contents of essential nutrients for plant growth, the use of this alternative source of water to prepare the irrigation solution may reduce the needs of standard commercial fertilizers and its associated cost. Is all. Thank you.
Mira, Rafa.
Thank you, Maria. I will give you a yellow card because you passed 1 minute, but I forgive you because I love avocado and your work seems quite interesting. Thank you so much, Maria. And now we go directly to Sweden, and we will have Ulla. Ulla, can you hear us?
Excuse me, now we
Yes,
have
I
a very nice tomatoes from our germo plant.
Maria, bye-bye. Ulla from Sweden, can you hear us?
Yes, I can hear you.
Hello.
But
How
I'm
you
sorry,
feel?
but I'm unable to start the video, so you will have to only have the presentation, not me.
Okay,
Okay.
no problem.
No problem.
Let's see if the presentation can... Okay, yes, we are seeing your presentation, Ulla.
No.
Thank you so much.
Okay, that's good, because I have just the chat disabled. It's just over all the, so I can't see my presentation.
How are you feeling today, Ulla? Are you okay?
Yes, I'm okay, thank you.
Okay, let's
Hope
start.
you are
5
too.
minutes.
Yeah. Okay, so hello everyone. My name is Ulla Chaudhry, and I'm representing AquaQ. Nu ska vi se. I'm representing AquaQ, a Swedish applied research SME engaged in water safety and security. Our goal is consumer safety and to protect environment with cost-effective solution which saves energy and no emission in the process of water reuse. Thank you for providing us this opportunity to describe AquaQ's technology, application, and customer benefits. AquaQ addresses global challenge of water shortage with the development of two separate novel standalone technologies, AquaTrack and ozone polishing, that is AquaRenovate. Eliminating online both pharmaceutical residues and pathogens that are always found in treated wastewater, even if it is treated with highly sophisticated, expensive technologies like membrane filtration. Treated wastewater is a resource for water reclamation which cannot be denied in water scarcity areas, but the water must be free from pathogens and pharmaceutical residues. No compromise on human health issues as COVID-19 is also found in treated wastewater. The water can be used for various industrial applications like technical water, aquifer recharge, and for irrigation of vegetables. Our technology, AquaRenovate, is patented and demonstrated successfully in Sweden without additional process step like granulated active carbon. Our practical applied research results shows that treated wastewater always contains harmful microcontaminants like pharmaceutical residues and pathogens that can be a dangerous threat to humans and aquatic lives. The discussion of today to establish a minimum water quality standard for irrigation is not enough. It must take consideration to pharmaceutical residues and pathogens together with removal of nitrogen and phosphate. Our AquaRenovate process can have an online monitoring and sampling role to protect environment and farmers' health. Next, please. I can't see the presentation, but I suppose it's number 2. This is our concept as a schematic process. Treated wastewater effluent is optically monitoring microcontaminants in the effluent, fingerprinting the stability of effluent quality from a wastewater treatment process. And when the deviation happens, the optical sensor reacts, collects sample, alarms the operator, and initiates the ozone polishing to eliminate the contaminants. Contaminants that are of concern are pathogens like E. coli, coliforms, and parasites like Cryptosporidium and Giardia, as well as pharmaceutical residues. The technology is EU ETV verified and have received several international awards. It needs to be applied in real case scenario together with an end user for long-term evaluation and adaptation. This table shows the existence of pharmaceutical residues and bacteria that we have found in our research in EU RJ Water project. After our ozone polishing treatment, the pharmaceutical residues and pathogens are eliminated below the limit of detection, and the water is safe to reuse for different applications. And the next picture. This picture shows some of our case studies from Sweden and Spain. This MBR effluent in Stockholm, and the irrigation and wastewater treatment plant in Spain, and the swimming pool in Stockholm, and wastewater to technical water in Sweden. Our mission is sustainable business development for safe reuse of water free from different contaminants for irrigation and counteract global water shortage. To mitigate biological and chemical risk in reclaimed water for reuse, our concept is real-time quality control, sampling and removal of pollutants by ozone polishing. And AquaQ seeks funding and cooperation partners to manufacture and demonstrate AquaRenovate under realistic use case scenario for safety and security for reuse of reclaimed water. Okay, so thank you.
Now, Ulla, thank you, and congratulations for your work. And now we are going to travel directly to Jerusalem, I think, for the Hebrew University of Jerusalem, Israel. And we'll have Eviatar Ben Mordechai. Is it?
Yeah.
Hello, how are you?
Yeah, you pronounce it very well.
Very well? Yes, I have been practicing for the last 3 days at least. So, how things in Israel?
They are a bit tough, but we hope that this war will end soon, and we hope that peace, that both sides will have peace and equality and prosper life.
That's what we hope. So now let's focus in our theme. And congratulations on your work. You have 5 minutes starting now.
Okay. So my name is Eviatar Ben Mordechai. I'm a PhD student in the Hebrew University of Jerusalem. And today I'm going to talk about contaminants of emerging concern, mainly pharmaceuticals, in fresh produce irrigated with treated wastewater. And it's actually a direct continuation of what Ula talked just now. So contaminants of emerging concern are being introduced into the agro ecosystem or to the field via treated wastewater irrigation. This is one of the major routes that introduces contaminants of emerging concern into the field. And in this study, we have examined 445 fields irrigated with treated wastewater, and we've analyzed irrigation water, soils, and fresh produce for traces of 65 contaminants of emerging concern, mainly pharmaceuticals. And you can see them here. We have fruit crops. You can see the tomato, the banana, the citrus, avocado. We have leaves, which are the leafy greens at the bottom, potato, which is a tuber, and carrot, which is a root crop. So before going into the main results of what we found in the produce, some words about the irrigation water. So as you understood, we've sampled hundreds of irrigation water samples coming from different wastewater treatment plants and wastewater treatments. And what you are seeing here on the x-axis is the accumulative concentration per sample, and on the y-axis is the number of analytes per irrigation water sample. And it is not a surprise that as the number of analytes increases, the accumulative concentration increases as well. But what is interesting is the definition or deviation or distinction between the different treatments. I will not go over the different treatments, but what you are seeing here in pink is the advanced treatment of soil aquifer treatment versus the secondary and tertiary treatment on the right upper side. And cluster analysis that we did shows in a very good way that the soil aquifer treatment is distinctive from the secondary versus tertiary treatments. We are talking about activated sludge and activated sludge and sand filtration. And this also affected the concentration in the irrigation water, in the soil samples and the fresh produce. So just a brief overview of what we found in the different crops. You can see the crops on at the bottom and the concentration on the y-axis. This is a logarithmic scale. And we are seeing here only several contaminants of emerging concern that were detected above 50% in at least one of the following crops. And you can see the huge variation, and it's important to note that the highest variation and the highest concentration was detected in leafy greens, and this is not this wasn't a surprise for us, as contaminants of emerging concern or organic pollutants are being translocated in the plant with the xylem sap from the root to the leaves and accumulate in the leaves. These compounds that you are seeing here, most of them they do not have any charge. They are neutral, which allow their relatively easy uptake into the plant. So the physicochemical properties actually have a lot to do with the uptake of these contaminants. And the lowest concentration were in the different fruits, as you can see here. So to sum up, all the irrigation, soil, and crop samples were contaminated with traces of contaminants of emerging concern. And this shows very nicely that treated wastewater irrigation is a major route or a main route for contaminants of emerging concern to enter the food chain. Thank you. Right on time.
Wow, wow, congratulations. Congratulations on your time, but also on your work. It was perfect. Thank you so much, Eviatar. I just remind the audience that if you have any questions about the abstracts, because we realize that you do have, or include on the chat and the authors can reply you directly, or you can contact the authors by the contacts that you have on the abstracts, okay? Because we won't have time for that. So now we will travel directly to Spain, yes, and we'll have Antonio Bolinches from Universidad Politécnica de Madrid. Antonio?
Yeah, good morning.
Hello, how are you? How do you feel,
Antonio? How are you? Happy to be here.
Okay, so the floor is yours. Yes, we can see your presentation. Don't forget the 5 minutes to avoid the yellow card.
Okay, I have the presentation, but I don't have the buttons to go forward in the interactivity part, so I will simply go to next slide. I will present our research on water reuse in rural areas. Yeah, here you can see the setup we are confronted with. So typically, we have different wastewater treatment plants, and we want to choose in which of them it would be more interesting to install a water regeneration plant, taking into account the costs that we would incur with and the potential benefits of putting land plots into irrigation. So next slide, please. Yeah, here you can see the methodology. On the one hand, we calculate the infrastructure costs and the operational costs for each one of the candidates. And on the other hand, we calculate the potential benefits that would stem from putting the irrigation, the land plots into irrigation. So we can compare for each candidate which would be better to put into this water reuse plot. Next slide, please. So the methodology involves a lot of equations. It might look confusing at the beginning, but I can assure you that taken one by one, they are quite simple to follow. The equations are quite justified. You go to the next slide, please. And one of the particularities of the project is that we begin with a minimum span tree algorithm. So we are able for each setup to calculate automatically which would be the pipe distribution that would bring the regenerated water into the land plots with a minimum cost or a minimum distance, depending on the criteria that we choose, taking into account the water demands of each land plot. So if you go to the next slide. Yeah, here we can see the results on the cost side. The font is a bit small, so you can, still you can read it, but each color represents a cost type. So on the light blue, for example, we see the infrastructure cost of actually building the regeneration plant. Then on the gray, we see the infrastructure cost of the pipes. On dark blue, the operational cost of the regeneration plant. So on the right-hand side, we can compare two different candidates. So on the right-hand, the extreme right, we see Alcázar wastewater treatment plant, which has a higher cost than the other one, which is Argamasilla. And the methodology is able to identify why it would be more expensive to implement this water regeneration plot in Alcázar with respect to Argamasilla. In this case, because the gray area is bigger, which means that the pipes would be more expensive to to introduce, in this case, because the land plots are distributed more far away with respect to the water treatment plant. On the left-hand side, we see a comparison between 3 different water regeneration technologies. 2 of them are ultrafiltration and filtration, which would reach the Class A of the European Regulation 741. And the other one, which we see in the middle, is cheaper because it would only reach Class B, which is less strict than Class A. So we go to the next slide. Here we see on the outer ring the costs, the same costs that we have seen in the previous slide. In the middle ring, we see the benefits that would come from putting these land plots into irrigation. And in the inner ring, we see the relative percentage for this particular case of crop type. Like in dark blue in the inner ring, we see the percentage of vineyard, and in the light blue in the inner ring, we see the percentage in surface of cereals. In this case, we see that the big majority corresponds to vineyard. The benefits are high, and in the hatched area, in the outer ring, in the upper left area, we see the additional benefits with respect to the cost, which means that in this particular application, we would have a net benefit. But this will be clearer in the next slide, if we can show it. Yeah. Here we can reach the conclusions. On the right-hand side, we see the 6 different candidate projects. The yellow line is the net benefit. It is a positive net benefit in the 3 candidate projects on the left-hand side, and it is a negative benefit. There would be no interest to implement water regeneration plans in the 3 candidates on the right-hand side. And we can also see that the main difference depends on the kind of plots that we would put into irrigation. On the left-hand side, the blue columns represent the high percentage of vineyard, which is a high benefit crop when it's put into irrigation. On the right-hand side, we see the green columns that represent the cereals that are bigger, that represent a bigger surface in the 3 candidate projects on the right, which represent less benefit. So in the end, it would be less interesting to put the water regeneration project in these candidate projects. So in the end, our methodology pretends to be an easy tool for water authorities to identify these water regeneration projects that would be priority. So here we reach the last slide. Here you can see a link to our blog, and thank you for your attention, and we are ready for any question that would arise.
Thank you, Antonio. This cost analysis is always important, and I also love the elevator buttons on your elevator pitch session. It's
so you know on which floor we are.
Yeah, thank you so much, Antonio. And now we are going to travel to Turkey. We will have Burcu from Turkish Water Institute. Hi, Burcu.
Good morning.
Hello, good morning.
Hi, you can see me.
I can hear you,
Hello.
I can see you, and I can see your presentation.
Great.
So, are you ready?
Yes, I'm ready.
Don't be nervous. Okay, 5 minutes.
Thank you. And thanks for including me in the session. And also, I would like to congratulate you all for the success of your project. So this is Burcu from Turkish Water Institute. I will give an introduction to our case study we are conducting currently in Konya Closed Basin in Turkey, which is on water reuse in agriculture. Actually, this is one of the 3 case studies conducted under the WaterMed project, which is funded by Prima. And very briefly, Prima promotes smart farming by enhancing efficient use of both conventional and non-conventional water resources in agriculture by using IoT technologies. So our focus area is Konya Closed Basin, as this is one of the biggest agricultural production areas in Turkey, with agricultural areas covering nearly 60% of the basin. Yet the basin has a semi-arid climate with non-homogeneous rainfall throughout the year and throughout the basin. And in terms of water resources, the surface water resources are quite limited. Therefore, the demand is mostly met from groundwater. And if we take a look at the crop pattern, the most widely grown crops are, unfortunately, the most water-thirsty ones, including sugar beets, sunflower, alfalfa, with all sorts of grains, fruits, and vegetables. So, as you can see, 94% of the water is used for agricultural purposes in the basin. So if we take a closer look at the water demand of the basin, you can see that the water potential is far from meeting the total water demand, which puts pressure on groundwater resources, as I mentioned, and which has led to over than 30 meters of water depletion in groundwater. And you can see one of the results as the background photo of the slide, which is the formation of very large sinkholes across the basin, and we are talking hundreds of them. So one of the first things we looked into as part of this project was the current situation of the wastewater treatment plants in terms of their capacities and technologies. So at the moment, nearly 60% of the wastewater is being treated, that's currently generated. And in terms of the technologies, you can see on the pie chart that mostly lagoons and biological treatment plants exist in the basin, with advanced biological treatments having the slightest share. And if we are to upgrade the existing wastewater treatment plants and add some new ones, we will be able to irrigate up to 10,000 hectares of land in the basin. This will not solve the problems of the basin, but it will be a start at least. So we also looked into the effluent qualities of the existing wastewater treatment plants, but since most of the treatment plants lack a disinfection unit, the F. coli standards did not meet the reclaimed water quality as indicated in the regulations. So as I mentioned, we need some upgrades in the existing wastewater treatment plants and additional ones to treat all the wastewater within the basin. And so far, lack of incentives and lack of investments hindered water reuse practices in Turkey. So we need to focus on and show the environmental benefits and socioeconomic advantages of using reclaimed water in agriculture, which is actually our purpose in our case study. We will be looking into the suitability of using reclaimed water in agriculture. We will be growing sugar beet and corn in our pilot study area. We chose these plants because these are amongst the most widely grown ones in the basin and also the most water consuming ones as well. We will also employ some agri-smart technologies in order to improve water efficiency, as this is one of the other issues within the basin. And all in all, we will combine the data we gather from the pilot study with the socioeconomic aspects in order to develop some best management practices in the end. So I would like to thank you for your attention, and for further information, you can check our project website. And I also would like to invite you to our webinar next Monday, about which you can find more info on our project website. Thank you very much.
Thank you, Burcu. It was fascinating, and we invite everyone to join your webinar next Monday. And now, well, let's continue. We return to Spain. Sandra Ricard, are you there? She from University of Alicante. Hello, nice to see you. So, Sandra, remind you have 5 minutes. We are waiting for your work.
Okay, thank you so much. Well, hi everyone, and thank you so much for the opportunity to share this brief review about the main driving factors considering the need to face with agricultural water scarcity, in taking the focus on southern Spain. So next, please. So we have identified by checking the literature and also considering some of the field works that we have carried out, that we have identified a threefold problem. So we have water scarcity, considering this both duality between real and constructed water scarcity. Next, please. We have also the problem of water pollution, that as you know very well, that it's a very serious problem with water contamination. And next, please. And also the water competition between different water demands, that maybe is the social side of the same coin. Next, please. So one of the solutions that have been promoted in order to achieve this threefold goal, or this close the gap of water scarcity, water pollution, and water confrontation or water competition, is the use of reclaimed water for agricultural activities. And in this case, we have more information about the benefits, but also we have to address different risks related to pollution, but also related to regulation and the YAC factor, the perception of end users. Next, please. So we have identified the main driving factors, these 5 factors from southeastern experience in Spain, in which we have identified 5 main issues to consider when trying to achieve this threefold problem. So water use, water cost, quality standards, the management, and the perception of reclaimed water. Next, please. So regarding the use, most of the studies have been focused on asking about the ecological flow, for example, because one of the main controversial issues is the environmental use of reclaimed water, and if this use could be applied in water scarcity or semi-arid contexts in which non-permanent rivers are the common. Next, please. Regarding the cost, most of the studies have been focused on the cost-benefit analysis, in which we have compared the reclaimed water benefits with regarding other water sources, for example, desalination. Next, please. And also the quality standards. In this case, most of the studies have been focused on the BB2 plants and the role of the water quality standards, trying to be more efficient, so ensuring the elimination of the conventional pollutants, but partially also regarding the pharmaceutical pollutions or the emerging pollutions, and how this could affect the health standards. And also the management. In this case, is one of the most interesting issues, because there is different topics in which we have to address. So there is a proposals for a sanitation fee, so a tax to try to promote the cover costs of the operating and maintaining these sanitation and treatment facilities, but also try to provide some agreements between different users. So, for example, water exchange between urban tourist site and agricultural site. Next, please. And finally, the perception, that is maybe the novel one and the understudied research topic, in which we try to put the focus on farmers. So which is the perception, which is the attitude, the predisposition to use reclaimed water. So which are the main barriers and the rejection factors, trying to depend on what is the ability of individual, but also farmers as a community, to address the gap to water scarcity using reclaimed water. So here you can see, as a conclusion, that this need to try to put the focus on or insist on this dual approach, so the technical approach and also the social learning approach, in which farmers are on the core on the analysis. And you can see some research projects and some recent publications that maybe could help to understand most of the issues that we have seen in these 5 driven factors selected. That's all. Thank you so much.
Thank you very much, Sandra. It's very interesting, your work. And now let's travel to Portugal. Here we have Joana Pinto Coelho from Águas de Portugal. Joana, are you there?
Hi, good morning. Yes.
Hello,
Can
good
you hear
morning.
me?
Yes, perfectly. Thank you to be here, to submit your abstract in your call, and you have 5 minutes. So the floor is yours.
Okay, thank you. Hi, good morning. So I'm the only Portuguese in this session, so I will try to keep in time. And I will talk about the production of water for use in agricultural irrigation at the Mediterranean Alentejo region. Given, oops, sorry. Right. Given the characteristics of the region and the growing effects of climate change, it was considered that it will be advantageous to develop a reuse project in Alentejo to promote this activity as an alternative and sustainable source of water on irrigation activities. Okay. The reuse project is a 3-year pilot project which aims to produce water for use through solar disinfection technology. These are our partners, and the project is coordinated by Águas de Portugal and is financed by the Portuguese Environmental Fund. This is very fast. So the project aims to promote the circular economy and the reuse of treated wastewater through solar disinfection in agricultural irrigation in Alentejo, a region that, despite the low rainfall and the emerging effects of climate change, hosts highly intensive agricultural practices. In order to apply the fit-for-purpose approach to ensure the production of safe water for the irrigation, as well as the protection of the nearby environment recipients, a risk assessment analysis was performed so that the methodology established in the European regulation and in the recent Portuguese law regarding water use could be tested. The water use effects in crop growing soils and water bodies were also studied in order to benchmark the environmental and economic performance of water use against irrigation. So this is the scheme of the pilot installed at Beja Wastewater Treatment Plant, which aims to test the water for use production system that incorporates a solid disinfection technology for polishing treatment of secondary effluent of the treatment plant for drip irrigation of a pomegranate orchard. The solid disinfection system consists of compound parabolic concentrator or solar photoreactors, which are static solar collectors made of a reflective surface with shape of the two truncate parabolas and a borosiclate tube. So the water recirculates through the CPC for the number of times needed to guarantee the exposure time and UV dosage required to attain the desired disinfection level. No, okay. The risk assessment developed through the risk scheme demonstrates that the impact of this water on health and environment recipient was negligible, and that implementation of barriers and good practice throughout the reuse scheme ensures the production of safe use of Class C or D of the water quality. These are the results of last year. In July, 2 rows of CPC were encapsulated, this gray box, with a thermal solarization plastic in order to raise the temperature of the water inside the concentrators above 45 degrees. However, this encapsulation resulted only in a slight increase in temperature, not reaching the goal of 45 degrees. And additional, we also saw the loss of QUV, decreasing the disinfection capacity of the system. So at the end of the month, we removed the plastic. According to these results, the objectives pursued were achieved in a very significant way. The solid disinfection technology produced reclaimed water with the required quality for the irrigation of the orchard, and no significant impacts were observed on the irrigation system, neither on the development of the plants and fruits. Considering not only the positive evolution of the reuse project, but also its importance as flagship to promote water reuse in the current context of climate change and increasing water scarcity, it was decided to extend the reuse project for another irrigation campaign. So thank you. If you have any doubts, please share with me.
Thank you, Joana.
Obrigado, Joana.
It's nice, very nice work. Now we go for Andres Acosta in Denmark. He comes from Aarhus University. Andres, are you there? Can you hear me?
Yes, I'm here. Can you hear me?
Hello, good morning, Andres. Nice to see you.
Good morning. Yes, same.
So you have your 5 minutes and they start now. Remember that we have the yellow card. So, Andres, let's share your work, please.
Can you share my presentation? Okay, thank you. So yes, my name is Andres Acosta. I'm a PhD student at Aarhus University, located in Denmark. I'm representing the Department of Chemical Engineering and Biology. I'm in parallel also project manager in TTZ Bremerhaven. And today I would like to introduce you to technologies which, when they are combined, we can recover many resources. So the first one is are the engineered wetland systems combined with the hydrothermal processes. So I would like to start my presentation telling you that this molecule called HMF is a building block or a platform chemical that we are aiming to obtain through the treatment. So this molecule is called a sleeping giant by our scientific community because it has the potential to replace the petrol-based chemicals that we are using. So through this building block or platform chemical, we can produce pharmaceuticals, we can produce bioplastics, we can produce biofuels, and even materials. So this HMF is indeed hydroxymethyl furfural. It's one of the molecules that we can obtain in our process. So that was called a sleeping giant. So we know now why it's a giant. It can replace the petrol-based chemicals. But why is it sleeping? So the answer is because it can be obtained by the dehydration of the cellulose. And if we combine this knowledge with the content of cellulose in the lignocellulosic biomass, we can see that between 40 to 50% of the cellulose content is in this kind of resource. So what we are doing at our university is to combine the biomass which grows in the wetland treatments after treating the wastewater, and then we expose that biomass to hydrothermal processes. So in our research, we are mainly focused at this moment in the willow system, in which we deal with the Salix viminalis. It's a beautiful plant which can grow for treating wastewater. So here you can see a picture how high they can reach. So I would like to introduce you more or less how are we doing it. So first of all, we catch the wastewater and then we treat it with a willow system and with one electroconductive constructed wetland. So after the treatment, then we can have water which can be reused. But with the biomass which is growing in the willow system, then we harvest it and then we insert it in a hydrothermal process where water with pressurized and high temperatures will transform the biomass. So this is a picture of how the willow system looks like. This is a system designed by one of my co-supervisors, Dr. Arias. And one of the things that we can produce with this hydrothermal process using the biomass produced in the willow system is that we can produce biochars, for example, which are very helpful for the soil amendment. And then we can also produce even advanced materials like the electroconductive chars, which they can be also reused in the electroactive constructed wetlands. So using that can help us to increase the load of the pollutants that we can deal in the wastewater. And through this technology, the hydrothermal processes, we can even produce also biocrude, which can serve as a fuel. So this is a picture of the pilot plant we have at our university. It's like 50 liters per hour plant. And you can see also a picture of our electroconductive constructed wetland, also designed by our Institute of Biology. So if you are wondering what is happening inside there, you will see that the water exposed to high pressure and temperatures we have self-ionization, which release ions which will catalyze the reactions. So those reactions in a control space and reactors then can help us to understand what kind of reactions are happening there. So we see how the cellulose is being transformed with the temperature and the pressure. So we can obtain not only all the things that I said before, but also high valuable molecules or building blocks. Those molecules, we are measuring them with GCMS and also with the HPLC to calculate and to see the yields. So the main message is that by the combination of constructed wetlands or the wetland systems and the biomass being processed by the hydrothermal processes, then we can obtain hydrocharts, which can be also activated as activated carbons, or can be can produce charts which can help us to recover phosphorus from the wastewater. We can produce also fuels like the biocrude. So if you get interested, I hope it's changing the slide. So yes, this is our team. This is the group of professors and senior researchers, part of our research team. If you get interested about the hydrothermal process, please feel free to contact our Department of Engineering. And if you get interested in the part of the constructed wetlands and the wetland systems, just please contact us with the Department of Biology. And as a conclusion, then we can see that the combination of the wetland system can help us to produce reclaimed water, but the biomass can be also processed, and that will help us for the transition of circular bioeconomy. Thank you.
Thank you, Andres. Thank you very much. It's very promising work in your after. And now we go for Germany. We have Farah Rashid Mir from TTZ Bremerhaven. I think that's a colleague from Andres. Hello, Farah. Can you hear me?
Hi, can you hear me?
Yes, I can do it. You can start with your presentation. You have your 5 minutes.
Just one point. Maybe I'm not looking in the camera because I have a different camera and the screen, so it's.
Don't worry. Focus on your work.
Yeah. Okay. Good morning, ladies and gentlemen. My name is Faraz. I'm representing TTZ Bremerhaven. I will directly go toward the topic. The topic is desalination of seawater for agriculture irrigation. It's a very innovative kind of topic, and we are doing a lot of research in this direction. The technology is membrane distillation, and it has several applications. Of course, one of the application is desalination of seawater. The agenda of my presentation is I will focus a little bit about on the objective and then introduction. Then I will show you the pilot plant which we developed, and then the results and conclusion. The growing scarcity of fresh water has driven to use of non-conventional and reuse water resources for agriculture by applying some efficient technologies. The need for water covers not only for the water needed for human consumption, but also mainly the consumption in agriculture industry. So that's why we focus to develop a kind of efficient technology which can be used to desalinate the seawater, which can be used for agriculture. And of course, we are focusing on the economic feasibility. So the membrane distillation is basically a thermal-driven separation process in which vapor molecules pass through a microporous hydrophobic membrane. Membrane distillation has 4 different kind of basic configuration, which is called direct contact membrane distillation, air gap membrane distillation, vacuum membrane distillation, and sweeping gas membrane distillation. I will show you a little bit more detail about these configurations. So you can see in the screen there are red lines, which is basically the feed side of the membrane. And then you have a light blue line, which is a permeate recovery, and the dark blue is basically representing the condensed water, which is used to condense the permeate, which is, so basically from the feed side, the vapor pass through this light blue side, and then you use this cool water to condense these vapors. So this is a configuration. This is called direct contact membrane distillation. Then we have air gap membrane distillation, where we have a condenser inside this membrane module, which you can see in this green color, and then you have this dark blue and the light blue. Light blue is for the covering of permeate, and dark blue is for the condensed water, and the red is of course for the feed side. Then you have a sweeping gas membrane distillation, which is where we use the air to take over the vapors and condense it. Then we have a vacuum, where we use a vacuum pump to recover the vapors and condense and recover it. So these are the 4 different configurations. Here you can see the pilot plant, the 3D diagram, and also the installed pilot plant. So we tested all 4 different kind of membrane distillations. We use the membrane area for each module is around 0.25 square meter. We use the different salt solution, like different composition of salt solution, but the standard was 35 ppt. We tested or we observed different parameters like temperature, flow rate, conductivity. We monitor online data and everything. The results shows very promising for direct contact membrane distillation, which is you can see in kind of yellow color. We found out that direct contact membrane distillation is the most energy efficient as compared to other 4 modules. And also with the regard to the permeate recovery, we found out that the direct contact membrane distillation has a higher permeate recovery as compared to other modules like air gap, vacuum, and sweeping gas. To conclude my presentation is that we found out, as I said, that the direct contact membrane distillation is easiest and fastest among all the configurations. PTFE polytetraethylene fluoroethylene membrane is better than polypropylene membrane. We also tested polypropylene membrane. We didn't found a lot of fluctuations in the system. We found out that the system can be really desalinate the water. If you have a salt solution of microsiemens, you can simply go to the millisiemens to microsiemens, like 200 to 300 microsiemens. The conductivity can reach after treatment. Membrane distillation can adopt effectively distillation techniques, and it has several applications like wine dealcoholization, orange juice concentration, high concentration, apple juice concentration, and so on. Thank you very much.
Thank you too for us. And to close our elevator pitch, we go to Poland. Marcena Small from Very Pass. Are you there, Marcena?
Yes, hello.
Hello.
Good morning to everyone.
Good morning. Good morning. Nice to see you. So you have your 5 minutes. Thank you to share with your work, and the floor is yours.
Okay, thank you very much. Hello, my name is Marcena Small. I'm representing Mineral and Energy Economy Research Institute of the Polish Academy of Science in Poland, of course. So we are only the one on this conference. And today I would like to show you the initial results of our project, which is the monitoring of the circular economy implementation in water and wastewater sector in the European Union. And the title of the presentation is Good Practices of Water Reuse as a Part of Circular Economy Implementation in Poland. So I think I don't have to explain that circular economy is the current European priority, for the economic policy of the European Commission. I just wanted to underline that we are working with the circular economy from the very, very beginning in the European Union. That's mean from 2014, when the first communication, like the official document on the circular economy, was announced by the European Commission, and that was the Zero Waste Program for Europe. And from the perspective of the water and wastewater management, the strong focus was put to the waste management. And in the water and wastewater sector, that's mean, okay, don't produce so much the wastewater. That's mean we have to more sustainable manage the water resources. And the second approach, please be more sustainable with the wastewater management, and that includes also the management of the raw materials, energy, and any other sources which could be recovered from wastewater. And I'm very happy that in the second Circular Economy Action Plan in 2020, more focus was put on the water instead of only raw materials. And it is also very connected with the implementation of the European Green Deal, the newest strategy for the European Union. So the water is very important. And in 2018, the Ellen MacArthur Foundation, with the collaboration with other environmental bodies in Europe, developed a very interesting document, which is a white paper on water and the circular economy. And here the three layers for the circular economy implementation in water sector were presented: water as a sources of energy, nutrients, services, so that was the starting point for our project, that the water is important. That's not only raw materials which are important in the circular economy. And we've created the proposal in 2018, which was submitted in 2019, monitoring of the circular economy in water and wastewater sector. And it was also connected with the issue that the monitoring framework for the circular economy on the European scale, that's only 10 indicators proposed in 2018. Of course, now we have more sub-indicators grouped into 4 groups, but not even one indicator was directed to the water and wastewater sector. So that was the, from our perspective, the missing point. And we wanted to propose some indicators for it and to connect this with the European Commission perspective. And that was the reason that we've used in our project the perspective of the waste hierarchy. Here you can see that there are 2 approaches. First one, this is related to the raw materials, including water resources management. This is the step before the waste generation. Yes, so we have 2 approaches. First, we have to focus on the raw materials management, and second, we have to focus on the waste management. And this is very connected with the definition of the circular economy that was proposed by the European Commission in 2014-15 in the first Circular Economy Action Plan, that the circular economy includes the raw materials management and the waste management. That means the resources from the primary and secondary sources. So in our project, we propose the framework for the monitoring of the circular economy in water and wastewater sector based on the waste hierarchy proposed by the European Commission. And it includes the reactions. First one is the rethink. Of course, we have to change our way of living, way of managing the resources and waste based on our changing of our mindset. This is very important, and this could be applied to any sector in the world. The second one is the perspective of our project in water and wastewater sector. That means reduce the generation of wastewater. It's also connected with the more sustainable management of the water resources. The second one is the removal. Here we have to remove the contaminants from the wastewater and water as well. Reuse. Here in our project, we adopt this for the non-potable usage of water. After is the recycling. The next one in our model is recovery. That means recovery of raw materials, including, for example, phosphorus or energy from any waste which are generated in water and wastewater sector. And after its landfilling, of course, we would like to avoid this one. So from the perspective of the current conference, in our project, we are doing the inventory of the good examples of the water reuse. And now we are developing the report, which will include many good examples for it, and it will be available on our webpage. Today, I would like to show you the very nice example of the water reuse in Poland, because of course we also work on water reuse from the technological point of view. And here you can see the innovative system station in Sędziszów Polski in Poland, in the south of Poland. And we've developed with the company Green Water Solution the rainwater recovery system, which is located in the station in Sędziszów Małopolski. And the train station toilets are supplied with the rainwater purified in the biological mechanical filtration process. And this is one of the first this kind of solution which was applied for the municipal station in Poland. So this is the biological and mechanical treatment and reuse of water, and we are searching in Poland now for this kind of solution which are already implemented. And of course the examples which you show us today during this conference will be very, very welcome also in our inventory in our project. I think that I will just underline that yes, we are in progress to transition to the circular economy, and the water reuse is very, very important aspect of it. For the beginning, we were working mainly with the raw materials. We participate with the development of the technologies for the recovery of phosphorus from waste generated in water and wastewater sector. However, of course, the water management is also very important, and it's clearly connected with the wastewater sector. So that was the reason that we also are very interested in water reuse. And also in Poland, since last year, there's a strong debate on the national scale on the solutions for the water reuse in our country. So thank you for your attention. If you will have any more questions or you want to see our project, you are here. I provided the webpage and contact to me. Thank you.
Thank you so much. Thank you so much, Marta. And thank you for you all for bringing your innovation and your complex work. Today we still have very good presentations, but the session will continue after a short break. We'll be back, let's say, at 11:15. Yeah.
Yes,
so
11:15.
Yeah, 5-6 minutes just to a short walk, have a coffee, check your emails. Please stay tuned, 11:15, and we'll have very, very interesting sessions after the break. Okay, so see you in a bit. Bye bye.
Hello again, and welcome back to the International Conference of Suwanu Europe. And we now move on to the second keynote speaker. Today we have Marta Carvalho from ADP, Águas de Portugal, who will give us a presentation about technology and innovation in water reuse. Marta Carvalho has worked for more than 20 years in the urban water cycle, with a focus on climate change, resilience, circular economy, and sustainable innovation. She is an innovation catalyst at ADP Valor within Águas de Portugal group, where she coordinates the research and innovation area. Marta, thanks a lot for being here. It's a pleasure to have you with us. Can you hear me?
Yes, Rafael, I hear you. Hello,
Good.
everybody.
Good. So the floor is yours. Thanks a lot for being here.
Thank you, Rafael. So, good morning, everybody. My name is Marta Carvalho, and I'll be giving you a talk. But first of all, I would like to thank you for inviting me to be here today with you. I'm really happy for that. And thank you, Rafa, for the kind presentation. My presentation will give an overview of water reuse in Portugal. I will also share with you our experience from the water utilities point of view. But first, let me give you some context. Let me start sharing Águas de Portugal Group a bit into detail. ADP is a state-owned holding funded in 1993 with the mission of designing, building, and managing water supply and sanitation systems in a framework of economic, social, and environmental sustainability. We are more than 3,300 persons, And the group has a gross fixed assets of 7.4 billion euros and serves 80% of the Portuguese population. This means that we are working with 8 million people throughout 13 water and sanitation utilities spread all over the Portuguese territory. You can see them in the gray area of the map. The group offers a wide range of solutions for different contexts, since Portugal, although a small country, is very diverse. So I believe we are posed at a critical moment in history. The demand for water and sanitation services has never been greater, and the role that water can play in improving women's well-being has never been more important. This justifies that during the last decade, water has been among the major societal risks according to the World Economic Forum. Of course, this was before COVID-19 pandemics, and curiously, this year, water is no longer under the top 5 risks. I wonder why. So, to face water shortages, special attention has been paid to water reuse in recent years because reclaimed wastewater can provide alternatives to existing water supplies and be used to enhance water security, sustainability, and resilience. However, water reuse can also pose risks to health and environment due to pollutants. And in order to reduce water reuse risks, several countries, mainly from South Europe, like Spain, Italy, Greece, or even France, have national binding standards for water reuse, where common quality standards are applicable to every project. This is the so-called fit-for-all-purpose approaches. But what about Portugal? Portugal, the water reuse strategy has been updated in 2019, and it is based on a different approach that includes integration of last developments of water reuse at European level, but also best practices like the ones developed by the International Organization for Standardization. That includes also multiple non-potable uses, not only irrigation for agriculture purposes, but also forestry, urban cycle, landscaping, etc. And includes also the assessment, from one hand, reclaimed water producers, and on the other hand, end users in order to overlap distance between both of them. And also includes a flexible management approach without compromising the health and environmental safety. The legal scheme that we have includes 2 laws that were published in the last couple of years. The first one is Decree Law 119 from 2019 that established the legal scheme for the production of water and for its reuse obtained from the treatment of wastewater, as well as the correct use in order to avoid harmful effects to health and environmental. The version is aligned with the fit-for-purpose approach, included in the regulation published last year at European level, and it's also submitted to the risk assessment and a permit procedure. The other law that we published this year in 2021 includes in the field of multi-municipality water system, the public service of water production for reuse. In practices, what this means is that the activity of producing water for reuse becomes part of the set of public services activities developed by the sanitation utilities, along with the activities of collection, treatment, and rejection of wastewater, which I believe will represent a major enabler for the water reuse activity in Portugal. In terms of practical way, how does it work, this water reuse activity? The Portuguese policy focuses on the adoption of projects supported on a risk management framework and in quality standards defined according to a fit-for-purpose approach, like I already mentioned. This concept entails the production of water for reuse with a specific quality that meets the needs in the specific case of the intended end users. So it's very focused on a case-by-case approach. All the projects shall follow a risk assessment under the permitting procedure aligned with that. And the quality standards applicable to each reuse project will be defined in each case study, and it will allow to select the risk management conditions that should be followed to ensure the minimum risk. As I told you, this is aligned with European regulation, but it's really different from other countries' approaches and current practices that are very aligned with the Fit for All purposes. To strengthen the enforcement of the new decreed law, in 2019, the Portuguese environmental authorities request ADP, but also all the other water utilities working in the country, to develop a water reuse action plan focusing on the group's largest wastewater treatment plants. The targets established by the government were to reuse 10% of our treated wastewater in 2025 and 20% in 2030 in the largest 35 plants managed by the group companies. In order to do so, ADP started developing a water reuse action plan, aiming at identifying facilities that could produce water for reuse, also to identify its potential uses and what were the investment requirements. These were in order to ensure water with the required quality, but also for the construction of the necessary updates, treatment solution and distribution systems. The plan also included the definition of the necessary measures for the promotion and implementation of reuse projects that would allow to comply with the goals defined by the authorities. As a result, we identified 54 plants and we included them into this action plan. And these 54 plants represent about 90% of the group treatment, wastewater treatment. Within the development of this reuse action plan, we also identify a set of challenges and barriers to reuse activities. That include, for instance, safety risks from inadequate levels of treatment, inappropriate treatment technologies and monitoring systems, including lack of real-time information, concerning public health protection, unclear and consistent and conflicting regulation, and this decree law that were published in 2021 was already a result from this identification and came like an enabler for the activity, as I already told you, but also cost of infrastructure upgrades, including systems, assessment, installation, and operation. Particular about cost of water for reuse activity in Portugal, I believe in other countries also, but in Portugal in particular, is a key challenge because although we suffer from water shortages in most regions, the fact is there are still other available and cheaper water sources, so it is a challenge to compete with all of that. In the last couple of years, we have been using innovation to help us overcome these barriers. We try to combine technology development with social innovation approaches, acting as an enabler for water reuse. I will now present you briefly 3 projects that we are participating with the combination of these approaches that I've just told you. The first one, Reuse, is a pilot project in Alentejo region, which already been presented by my colleague Joana, that was launched in 2019, aiming to test solutions to produce reclaimed water that incorporates a solar disinfection technology for polishing treatment of secondary wastewater. The project seeks to enable the use of water for reuse in agriculture through leveraging the development of a low-cost technology and combines the opportunities related to Alentejo region, which include the reduced scale of plants, river basins profiles, rates of sunshine, and periods of irrigation, with the goal of fostering the value of water from across the diverse perspectives. This includes water availability, but also micronutrients recovery. The water is then used by local farmers for the irrigation of permanganates to study the effects on crops, soils, and water bodies to benchmark the environmental and economic performance of water reuse against irrigation with natural water sources. The project also seeks the protection of the nearby environment recipients by developing a risk assessment analysis using the methodology established by the Portuguese legislation and the fit-for-purpose approach. This is extremely important since Alentejo is a region that, despite the low rainfall and the emerging effects of climate change and heat waves, hosts highly intensive agriculture practices. The second project that I'm bringing you today is Life Phoenix, which is a project that has been launched last year under a LIFE program funding and aims to develop and test modular, flexible, and efficient solutions for the sustainable and safe reuse of secondary treated wastewater in accordance with European standards identified for Class A quality. This involves the development of two different modular solutions adapted to small scale and the other one to medium to large scale wastewater treatment plants, which are to undergo testing at a set of 5 plants, both in Spain and Portugal. The solution will be adapted to wastewater size, the wastewater treatment plant size. For instance, for medium to large wastewater treatment plants, we will study intensive advanced solutions like microfiltration, dissolved ozone flotation, activated carbon solutions. Concerning to the small plants, the solutions will be a combination of nature-based solutions with other, including raceways and algae ponds. Once again, Life Phoenix seeks ways to convert wastewaters into a resource for reuse in agriculture irrigation in a safe and efficient manner. The project also includes a specific development, which I think it's key, which is a decision support system and a sustainability tool to ensure feasibility for each wastewater, assessing the regeneration treatment to be implementing, in providing data for informed decision-making on the solutions available and how much they will cost. The last project that I'm presenting you, the last example, is Aquavini project, which was launched this year. The Aquavini project aims to contribute towards promoting the production and application of water for reuse in the vitiviniculture activities ongoing once again in Alentejo region. The project also seeks to contribute towards deepening the technical knowledge on water use in irrigation activities, the effects of its application to crops growth, as well as the impact on soil and water in addition to the irrigation systems. Under this project, we also intend to extend the definition of circular economy by applying olive pit as means for the filtration treatment of water for reuse. Additional, a communication campaign is to be held for raising awareness both near farmers and also water utilities. Like reuse, this is a joint project between water utilities and farmers that collaborate on a common goal to a more sustainable and secure water use. Thank you so much for your attention. I'll be very pleased to answer any questions you might have.
Thank you. Thanks a lot, Marta, for your inspiring presentation. And well, I do have one question for you. You were mentioning social innovation, and I would like to know how you have taken into account participation or engagement of different actors in the innovation process. How was it for you in Águas de Portugal?
We think that, thank you, Rafa, for your question. We think that collaboration between the different players is key. So we are now thinking about, we collaborate between water utilities, farmers, also farmers associations, also environmental and agriculture authorities, and we involve them in the project, in all projects from the beginning.
Good. Yeah,
most of them like partners. Yes, sorry.
Yes, I see that FENAREC, it's also one of our partners in Suwanu Europe, has been collaborating with you in Águas de Portugal. That's a good sign.
Yes, FENAHEG is also collaborating with us. Normally, we have an advisory board that also follows the project developments. And for instance, FENAHEG has been with us in some of them, yes.
Great. Okay, thanks a lot, Marta. We have to move on because there is some delay, so there's no time for more questions. Thanks a lot for being with us, and yeah, we now move on to the next session. Bye and have a nice day.
Thank you, Rafael. Thank you.
Good. So now we will have our roundtable. I'm very proud to present our partners in Suwanu Europe that will be participating in this session. As we mentioned yesterday, last year it was approved the European regulation on minimum requirements for water reuse. I was also commenting this in the morning. The idea of this roundtable is to have an open discussion on which are the best strategies and measures under this new scenario. I will start with the first round of questions to our panelists, and then we will have also some time for the audience to post your questions to our experts. So you are please feel free to participate and to ask whatever you consider and to include your comments. So hello, I can see you, Adriano, Diego, and Despo. Great, you are with us. We are supposed to have also Rafael Mujeriego, but it seems he's having some connection problems. So they will try to connect with him. It's fine. It's not a problem. Then I will start with Adriano Battilani. Adriano. Yes. Adriano is the General Secretary of Irrigants d'Europe and Senior Researcher at Canale Emiliano Romagnolo. Adriano, I have a question for you. As representative of European irrigators in Europe, what's the vision of farmers in this, about this new European regulation? Do you think that having an harmonized legal instrument for all European member states will reduce farmer reluctance to use reclaimed water? What are your insights on this issue?
Thank you, Rafael. Can you hear me?
Yes, perfectly. Loud and clear.
Okay. Thank you, Rafael. For sure, the new regulation that we were supporting since the very, very first steps in 2014 is an important piece of law that will allow us to have a better, let's say, relationship with the water use. But according to my experience, I do believe that to have less reluctant farmers means that we have to answer many questions that still are not fully answered. There is too much uncertainty for the farmer sector regarding the water use. For instance, one of the questions they are normally posing is it safe for our soil and for the operators? We know that there are studies, we are participating, our research institution to many of these studies, but when you go, for instance, for microplastics are accumulating into the soil and are not covered properly by the regulation. It's a matter of the risk assessment and the site-specific agreement we will have to find with each of the wastewater treatment plant. Another question is normally how much I will have to invest to adapt my irrigation equipments. There are problems. There are technologies that are not fully suitable with water use, mainly if there is a too high level of suspended solids. We are going toward the digital agriculture with high capability to save water, but if I have to implement an ultra-low flow drip system that need well-filtered water, I could have some problem. They ask, for instance, if they will be limited in the choice of the crop. So also on their access to cash crop that will allow them to have a decent income. They are fearing to become 100% totally dependent of the wastewater treatment plant, so to use only wastewater and not to have the possibility to continue to use the surface water and the groundwater for which sources they have permission. So they are scared, really scared, to have to pay too much because they are now under pressure in many countries because the bill of energy of irrigation, that to be effective is all pressurized nowadays, is increasing and is already reducing too much marginality. If we have to increase as well the cost of water, there is no room. There is really no room for further and unexpected cost increase. So they are also thinking about the limitation the recent farm-to-fork strategy has imposing in the use of nutrients. In many cases, wastewater is bringing uncontrolled amount of nutrients that must be accounted in order to fulfill the farm-to-fork requirement. So the sector is very interested. There is many advantages, and the farmers are conscious that we need more water in the future. So this law is helpful to avoid trade barrier, is helpful to harmonize the systems, is helpful, as we saw in the experience in Portugal, to start having a good inter-election, a good joint, let's say, joint job, doing together in a participative way a more integrated water management in between the urban area and the rural area that are surrounding the urban agglomerates. So we are absolutely positive in that sense, but still there is, I think, a justified resistance because whoever entrepreneurs that has to invest his own money or to take more risk in their own business want to be in a way secured. It want to have a clear answer and a clear outlook in order to drive correctly his own investments.
Thank you, Adriano. I believe that this uncertainty that you are talking also could be somehow supported by our results in Suwanu Europe. What do you think, Adriano? How helpful will be our materials for farmers?
Is important, I think, mainly to share the knowledge and to have a good common ground to develop answer, but also to overcome the public perception that is always negative, to convince the standard certification, the private or public certification that are putting standards and the farmers have to fulfill, and also to let the farmers have some more element designing their own water reuse irrigation system, because it's not a water use schema, or to have an idea of what will be their position inside the water use schema we will have to develop side by side. I think that the point that still has been not really understood or fully understood is the relevance of the fit for purposes. If we start proposing solutions that are customized, participated, and in a way we are proposing to the specific user the solution for their specific problems, many of these uncertainties will disappear.
Okay, thanks a lot, Adriano. Now we move with Despo Fata Casinos. She's a senior researcher at the Department of Civil and Environmental Engineering and at NIREA's IWRC at the University of Cyprus. Despo, you have a remarkable trajectory on the study of emerging pollutants in wastewaters, such as pharmaceuticals or antibiotics. Do you think that the new European regulation is facing this topic adequately?
Well, hello everyone. Thank you very much, Rafael, for the very relevant question on a quite timely topic. Can you hear me well? Yes.
Yes, perfectly. Perfectly.
Okay. So during the last 2 decades, I think that innovative analytical techniques have enabled the identification and quantitation of a very wide variety of chemical microcontaminants, widely known as micropollutants, in treated wastewater effluents. It is true to say that as soon as we know a bit more about some of them, concerning their potential fate and effects in the environment, another group pop-ups. Now we can even perform suspect or non-target analysis, identifying and quantifying thousands of compounds in one sample. So you understand that the questions are many. The questions relate to whether these compounds can be harmful in the environment, in which concentrations, whether individually or when present in coincidental mixtures, that is when compounds are present by chance in combination with others that may have possibly the same mode of action, how their physicochemical characteristics affect their fate and effects, and so on. Hence, we need to address numerous scenarios. On top of that, such scenarios should be assessed in the framework of varying environmental conditions, including temperature, humidity, pH, and so on. So to answer questions like this credibly, we need to perform assessments towards relevant organisms, including flora and fauna, and we need to unanimously design upon trigger values. If we focus now specifically on reuse, it is true that the knowledge has progressed greatly during the last decade. For example, we know that crops can take up microcontaminants. We have seen that during the elevator pitch session. Just to provide some examples of what we do know in more detail, I would say that the more polar compounds can be taken up by crops that can transpire more water. We know that weakly acidic compounds, such as, for example, diclofenac, are preferentially translocated in the phloem rather than in the xylem, having as a result their accumulation in the fruits. Also, we know that plants can metabolize these compounds, and therefore, when assessing effects, we need to consider those metabolites as well. The knowledge, however, that we have obtained so far concerns very specific studies, only few of which are under real conditions, mainly coming from Israel and Cyprus. Also, the information we have does not apply for all soils and for all environmental conditions or for all irrigation systems. We do not know much yet whether such contaminants can accumulate in humans through consumption, how the age, weight, or the diet, and so on, affect the accumulation, and most importantly, in the case they do, what they can really do in such minute concentrations. The regulation of reuse may not include environmental quality standards for such compounds specifically in Annex 1, but it does open the door to do so in Annex 2, in the framework of the risk management plan. And this is quite remarkable and I would say groundbreaking. Not only we have a regulation for the very first time that refers not only to pharmaceuticals, but also to disinfection byproducts, other micropollutants and microplastics, and also to antimicrobial resistance. At the same time, we mustn't forget that this regulation presents minimum standards. Therefore, the regulation does not ignore at all, in my humble opinion, the importance of these contaminants. And even though the scientific answers are possibly a bit unclear for the moment, and in some cases, it takes the lead, this regulation, and requires for this to be included, and rightly so, according to local conditions, needs, specific applications, and so on. Thus, the various countries are free to develop their plans, considering these issues with studies and solutions that will be tailor-made to specific situations and irrigation schemes, also by including the point of use and not only the exit of the wastewater treatment plants. There are also other important pioneering aspects in the regulation, in my opinion. The regulation, instead of selecting 10 or 20 micropollutants to follow and monitor from a list that admittedly will never stop evolving, and be dependent therefore on a procedure that would potentially never be able to form a solid basis for a regulation like this, it does require hazard identification and risk assessment, and it refers clearly to those response relationships. In my opinion, this is exactly what is needed, to apply bioanalytical tools that would be able to capture the global quality of the wastewater and the potential effects. I had the privilege to chair the cost action ES 1403 called Nireus on these exact challenges. What I can say with confidence is that we need urgently bioanalytical tools of a much higher technological readiness level. To sum up, I believe that it is remarkable really that the European Commission within 4 or 5 years managed to reach a consensus among a great variety of stakeholders, including the scientific and experts community, and published the reuse regulation as we all know it. In the era of circular economy, the regulation comes in to transform wastewater into a resource. We need to stop generating wastewater and rather run to create new water out of it. The regulation is published and the tools and the framework are here, and the Commission already works on developing guidance and acts to facilitate the implementation of this regulation and how the countries will implement the risk management plan. And the Commission leaves the floor open to the Member States to recognize local specificities and adapt their policy accordingly and include all the hazards and risk relevant. And I believe that this process is really fundamental to develop practically relevant risk management plans, taking into account the local territory of reclaimed water reuse schemes. So this is my answer to your question, Rafael.
Good, very profound and deep answer. Thank you very much, Despo. Thanks a lot. Now we have also with us Diego Berger. He's International Special Project Coordinator at Mekorot. He was with us yesterday. Diego, you presented your case study yesterday. Israel is a pioneer country in terms of water reuse. But we have discussed previously about what's the problem with Europe, why we are so far to achieve our targets. So in your experience, what do you think the European Union should prioritize to increase our shares of water reuse?
Okay, thank you, Rafa. I want to congratulate also Adriano, Despo, and Rafael that are together with us in this round table. And I want at the beginning to address what Adriano said, because Adriano, you said that there's a lot of uncertainty, okay? And all the how we plan the water sector, and we are dealing with water resources, is dealing with uncertainty. It's impossible to address the whole solution and to be certain about all the parameters that are inside the water use of effluent. And that's why in Israel at the beginning is that we know that was a decision because there was a very huge need of water resources. So it could wait for the perfect project. But at the end, they decided to start to promote the water reuse and to convince the agriculture to do that. And that's why when Adriano and we talked also when we met last year that it's a little bit disappointed that in Europe they are trying to convince the agricultural sector for the last almost 40 years. In Israel, it started to reuse effluent in 1985, and since then, and I think before in Europe, start to talk about that. And it's a little bit disappointed that we are in the same point, and this is a huge advance in everything that is related with technologies, and we can see also all the let's see the presentation that were yesterday and today. all the universities and all the organizations are working very hard to improve the technology. But at the end, I think that the problem is how to implement policies, how to convince that at the end, for 30 years, we're trying to convince the farmers to reuse this water, to use this water. And I think if you ask Rafa in which point we have to, let's see, to concentrate, I think that, or to be focused, I think is to how to implement policies, how to try to change the behaviors of the farmers and the water sector. And this is a thing that is very complicated to do. And one thing that I think that should be, maybe it's a way to convince them. When we talk about climate change, we know that there will be a lot of difference or changes between one year and the other. That means that maybe 1 year we have floods, or 2 years, and we have 3 years of drought. And the only two water resources that will not be, let's see, influenced by the climate change in a large quantity is the desalinated water and the water from the effluent, the reuse of effluent. That's why I think a way to convince the agricultural sector is by, let's see, explaining to them that if you use this kind of water that you can be sure that you will get, you will be less vulnerable to the climate change. And this is the way, because for 30 years they're trying to convince with different tariffs, with different policies, but again, we are still talking about the same things. That's I think that is a way to see in a different approach. Yes, Rafa.
Yeah, thank you. Thanks a lot, Diego. You're always brilliant.
I don't wait in that. Adriano has to answer after that. He has the right answer always. So
good. Well, I'm very happy to have also here with us Rafael Mujeriego. I'm glad you finally solved your connection problems. Rafael is Professor Emeritus of Environmental Engineering at the Universitat Politécnica de Catalunya, and he's also the president of ASERSA, the Spanish Association of Sustainable Water Reuse. Well, Rafael, you were involved in the development of the water reuse regulation in Spain, and you have also a profound experience and knowledge of water reuse, also experience of what has happened in other countries and regions like California. So you know very well this field. So in your opinion, which will you say are the main benefits of the current European regulation?
Thank you, Rafael, for your kind words. It is a great pleasure to be here today with you, together with such a group of distinguished colleagues. In my opinion, the practical application of Regulation EU 2020/741 will result in water reclamation projects with higher reliability features, capable of ensuring higher public health and environmental protection. It will also promote and improve design and operation of the wastewater treatment facilities that produce the treated effluents that flow into reclamation facilities. In summary, both reclamation facilities and sanitation facilities will be significantly improved, resulting in higher environmental quality of river flows and reclaimed water for the intended uses. Although that may sound like a future achievement in some cases, we have to emphasize that similar regulations have been adopted for years and are already resulting in very high reclaimed water quality, used for irrigation and numerous other beneficial uses. Let me emphasize the tremendous progress made during the last 4 decades in water reuse in numerous territories. Reclaimed water for agricultural irrigation has expanded into other uses with much higher quality requirements, like those needed for groundwater recharge, surface water augmentation, excuse me for my voice, and indirect potable reuse projects involving hundreds of cubic hectometers of water per year in some cases. Those 4 decades of continuous practice, adaptation, follow-up, research, and regulation could be summarized into 3 main points. Number 1, agriculture and landscape irrigation with reclaimed water has a long and successful tradition of more than 40 years of practical application in the Spanish Mediterranean coast and the Southern California agriculture and urban areas, all characterized by chronic water deficits. Number 2, we have a large scientific, technical, and practical knowledge on how to produce high-quality reclaimed water. We have a great diversity of available technological solutions for reclaiming water up to the desired quality level. And do we have numerous economic, financial, and managerial tools for the design and operation of the most diverse water reclamation and reuse projects? Number 3, the permanent support of water reuse regulations by public health and water resources agencies in close coordination with water utilities and users is a determining factor for achieving a proper public perception and a favorable user acceptance of reclaimed water. Beyond the approval of specific regulations like the European regulation and the continuous development of water reclamation technologies that we see every day, all we need is a proactive, coordinated, and strong support, particularly from public health agencies, for promoting reclaimed water for agricultural irrigation at this moment in Europe. Why is that? Well, because water reclamation raises a fundamental perception issue among populations and organizations. After centuries of precautions and cultural adaptations concerning wastewater as a disease vector that ended somehow with the adoption of industrial disinfection processes for drinking water in the early 1900s, people are now uncomfortable when confronted with the possibility of using reclaimed water for beneficial uses that imply a potential exposure and even ingestion of some of the contaminants initially present in wastewater. Although current wastewater treatment processes, coupled with additional water reclamation processes, have demonstrated their ability to purify water to the desired limits, users and consumers need to be reassured by public health authorities and water resources agencies that using reclaimed water with adequate quality for the intended use carries a risk level that we could consider tolerable, acceptable, comparable to that involved when using traditional water supply sources, either surface waters or groundwaters. Let me add a few more couple of questions here. The COVID-19 vaccine development and its application to large populations offers an emblematic, almost perfect example of the fundamental role that the support of public health authorities play in ensuring a good public perception of the vaccine merits, the benefits, and a favorable acceptance from citizens that are willing to receive it, even after considering the acceptable, limited, more favorable risk involved as compared with the alternative of not being vaccinated. We have made tremendous progress in the scientific and technological knowledge of how the virus and its variants operate. We have developed highly sophisticated technologies for producing the vaccine, storing the vaccine, and administering it to people. And we have developed quite a diversity of economic and financial protocols to bring about those vaccination campaigns. However, the support of national and international drug agencies in evaluating the risk involved and persuading people and politicians on the benefits of getting vaccinated has been fundamental in promoting a large-scale vaccination campaign despite the reported risk other than contracting the disease itself. Just to finalize, in a subsequent question, I may address the issue of the cost, which has also a very simple answer. It's necessity. Water reuse is not a hobby. Water reuse responds to a necessity. If we need water, we'll have to use that one, because this is the one we have. Thank you, Rafael. Thank you for the colleagues, and I'm open to subsequent questions and comments.
Okay, thanks a lot, Rafael. Thank you very much for your inspiring words. I'm glad that you emphasized the role of the public sector. I fully endorse your words about that. Let's go back to Adriano. Adriano, you were commenting before the challenges of farmers. You were commented the uncertainty that they have to face, especially in this new scenario. Well, I would like to ask you if in this new scenario, do you think it will be necessary to change, to modify the irrigation management policies, practices, and also agricultural water governance schemes? And if yes, to what extent?
Yes, this probably is also the answer to Diego. We have to program some investment. Let me point out the difference in between Israel and Europe. In Israel, there was two conditions. The first, absolute needs, as also Rafael has recalled before, the needs. There was no alternative. In Europe, we still have countries that are denying the possibility to reuse because still they have enough water, although in the last 3 years they had dramatic drought spells and serious damages to their own agricultural sectors. But their concern at the moment is how to have derogation. So this is the context. The second point is that in Israel, I'm always admired in the way you were managing. You have only one governmental or private, I don't know, institution, well trusted, Mekorot. In our situation, it's totally different. There is a fragmentation of the wastewater agency that are managing the wastewater treatment plant, in which in many areas are managed by the communes. So, to building confidence, to building trust, that is the main value. The trust is the main value for all the investors. We can lose all our savings on the stock market just because we don't have any more trust in Lehman Brothers, and we know what happened. So that's the point. We have to focus on the risk assessment. We have to focus on a specific analysis of the hazards, and we have to focus on site-specific reuse schema that are made together with all the players, including the farmers, that in that way will be more confident, will have somebody to refer, and will know what kind of investment they have to do. Because it's obvious that we will have, from the Agricultural Water Board, we will have to change our governance, we will have to refurbish or modernize our infrastructure. In some cases, we will have to separate the infrastructures. So there is big investment. At the farm level, they will have to change some irrigation system. They will have to implement more filters. We are talking freely about the possibility to have a further refinement of the water at the field level. So develop technologies that are, some of them are already good prototypes, that can allow us to refine the water at the level that a specific, more sensitive culture can require, in order to don't oblige the wastewater treatment plant to treat at the maximum level, that is a kind of hide precautionary principle and is not beneficial for nobody. So there are investments that we will have to do as a water manager sector, agricultural water manager sector, and as farmers. This investment requires trust. To require trust, to have this trust, we must clearly know what we have to do and what are the risks. So the process that the European regulation was putting in place, I repeat myself, the fit for purposes and the risk assessment based management of the reuse schemas are breakthrough in the context of the European and I think worldwide rules, because for the first time a law is putting rule that must be set and customized and tailored on the specific situation in order to maximize the impact. This is what we need to be confident and to invest, because there are large investments that we will have to do.
For direct comments, do you have anything to respond to Adriano? Anything to add from your experience?
He's responding, but we can.
Now we hear you.
Hello?
Yeah, now we hear you.
We can talk for hours, I think. Adriano, but at the end, you talk about something that I just wanted to address, that is the trust. That everything is built on the trust. And you mentioned a lot of things, a list of things that should be fulfilled in order to promote the reuse of effluent. And trust is the main thing. But again, during 30 years, we are trying, or in Europe, they are trying to build this trust and to convince the farmers to reuse. My question, and I don't have I want to be optimistic for sure. But what do you think, if it's feasible to at the end to convince the farmers to do that? Because I think that is a lack of trust, and that is very deep. So how to rebuild this trust? In Israel, for years the water was subsidized for the agricultural sector, and we also built a large network to supply water to agriculture that was from the beginning potable water. But that's the way to build the trust between the governmental agencies and the farmers. I don't know, and again, it's the main problem here, that you have to change now the culture and the behavior of a large part of the population. How you can succeed in this task? And again, we are talking about a process to rebuild this trust and to fulfill all the points that Adriano was addressing. I think that take at least a decade or more. So the question is, who could try to do such a thing, and what is necessary to achieve the success in this? I don't really know. This again, I want to be optimistic, but I want to hear from you if you can be optimistic. You are in Europe.
Thank you, Diego.
Andrea is always smiling, but Rafael also is optimistic. One thing, Rafael, you were talking about the vaccine, the vaccination, but the alternative was or die or to get the vaccine. In water, the farmers are getting the water, so it's not the alternative. You have to shut down this water supply, so they will have to use.
Rafael, do you want to comment on this? So I know you are very optimistic, so your words will...
Yes, I'm very optimistic.
Well, my opinion is that, again, the key word is necessity. If you don't need that kind of water, you will not be inclined to use it. However, let me say that there are other motivation, other reasons for recurring to reclaim water, that is environmental protection. You know that Directive 91/271, which is already almost 30 years old, requires countries to produce an effluent with 25 suspended BOD and 25 or 35 suspended solids. We should, in the near future, we should already have done it, improve that quality so our rivers and our environment achieves a much better quality. That is something that you can achieve with reclamation. And this is the reason I can explain to you when you ask me about to refer to an emblematic case in Spain. I would say the Murcia case is probably the most emblematic. Before I go into that, going back to the question, how do you proceed? When you want to introduce a new product, a new idea, all you have to find is volunteers, like the vaccination, volunteers, and show up the results. This is what the European Drug Agency is doing. They conduct a study with volunteers, they show the results, people are convinced, and they proceed with vaccination, one vaccination, two. So if you allow me to take the floor, I can explain basically what the rationale of the Murcia region that resulted in reuse by necessity, by environmental protection, altogether, including the cost issue, which is the main cost. This is the main reason. Cost is certainly a reason. But starting from the last idea I have on that particular subject, it is worthwhile to watch an interview of farmers, California farmers, in 2011, when they were interviewed in the Salinas Valley, which is close to Murcia region, $5,000 million of production. They reply and said, at the time we were offered reclaimed water, our concern was not the cost. The water was of better quality than the one we had before, because the one we had before was very deep in the aquifer, very depleted aquifers, saline already. The farmer says, the question was, would we like to continue being a farmer, or we will be willing to abandon our fields and do other business? That's the ultimate question.
Yeah.
So
I would like to hear also from Despo. Despo, I know you have been involved in the efforts of the European Commission to develop.
Before this question, can I add a comment on the previous
question?
Question?
Sure. Please go ahead.
One. So I fully agree that everything depends on the necessity, and as we say, both here in Cyprus and Israel, I think that wastewater reuse is a matter of survival for places like the Eastern Mediterranean. And also, I remember myself growing up with the slogan on the TV, not a drop into the sea. So the education and the information that the government offers to the wider society is very important. And another important aspect, I believe, very clearly, is that the farmers should have the right for easy access to information. For example, the Agricultural Research Institute here in Cyprus very frequently organizes this kind of workshop, or the university, and the farmers are invited to hear possibly about quite sophisticated studies on the uptake, but they know everything. I don't think that they are afraid that something is hidden, or the scientists know something more. Everything is open. So openness and the right to access is very, very important. And that was my quick comment.
Thank you, Despo. Yeah, transparency, openness and transparency is absolutely crucial here. I agree. And I would like also...
I also want to put...
Please, Diego, we want to hear you.
I cannot be without talking, but again, and Rafael also addressed that he said he has to convince also Despo. You have to present and to try to convince the agriculture about the technologies. But in Europe, you are trying to make a pilot about technology that are already proven in other places. It's not a new technology. And in most of the places, this is a trying to convince. This is part of the process. But at the end, remains with the pilot, okay, with the trying to convince the agriculture. Not in all the places, Rafael, not in all the places, but in most of the places that there's a pilot for, let's see, for convince the agricultural sector, the farmers. And again, we are talking about the main thing here is to build the trust and to have a very clear policy to encourage farmers to reuse. Everything that the technology will arrange very well around this.
Good. I see that Rafael wants to react on this, so please feel free to comment, Rafael. And maybe also
you can go on, Rafa. We will continue to discuss.
No, the idea of this session is to be interactive, so I'm very happy that we comment on each other. So, Rafael, feel free to add your comments.
Thank you. I just want to contribute. The idea was brought about information, and it's true. We need to document what we do, how we do it, in many different aspects. But the convincing process is not as much as the farmers reading those documents, which they have to, is talking to other farmers. In Spain, most of the coast, we don't operate on pilots anymore. Murcia is not a pilot project. Murcia is 110 million cubic meters per year. Consorcio Costa Brava is the same, millions of cubic meters per year. Of course, there are many pilots being done for technology. Having said that, I remember my own experience when trying to convince golf course directors and greenkeepers about the benefits of reclaimed water. And it didn't take too long before I realized that I was not a good convincer. I was at most an ambassador. So all I have to do is introduce this general manager to this other general manager, and then please excuse myself, I have to go. So all they have to do is talk to each other, look at their eyes, farmers look at their eyes and say, does it work? Is it good for you? Yes or no? If it's yes, there's no more need for talking. Just do it. So it's true that dissemination information is good, but it's not professors like me or managers or scientists that are going to convince those farmers. All we need is to convince probably one with a good demonstration or visiting one facility like in Murcia where they are already doing it, or Consorcio, or Barcelona. Once they see that, if they need it, they will do it.
Very interesting, very interesting. Adriano, do you want to comment on this?
Yes, I want to comment about Diego and Rafael. Okay, that's absolutely true. What is probably one of the main problems approaching farmers is that all of us, we are or scientists or technologists or professor or something like this. But before to demonstrate something, you must attract the people in order to have their attention. And what we are doing normally, not us as a scientific community or as policymaker or manager, what is the society doing normally is scaring farmers. If I have to talk about how many times I have to justify the reference in the policy as alternative water, which means literally that they will have to use the reused water instead of the water they have already. This is something that is scaring. It's a big change. Let's talk about integrative water, something that will help you to have the amount cannot be secured now, and then the access to environment. We are talking about substituting their water with something they don't know in favor of somebody else that is the environment. For who has to make their life on this piece of land is quite scaring. It's scaring that we are talking about water quality, and then in the canal we saw that the overflow and the bypass is letting a lot of untreated water. There are problems that must be solved before to offer, because I cannot go to the farmer and say, okay, the water I will provide you is of excellent quality when he has the smelling stuff into his own canals. We have a lot of these examples, So to build such kind of trust, to have a good reaction, we must have a positive narrative before. In the press, I can read, even in the barber shop, in the stupid review in the barber shop, there are about microplastics. This is scaring. Who has to produce? Because the consumer will not buy nothing if they has the idea that there is microplastic in what they are eating, although they are using toothpaste that contain microplastics. So that's the point. We are not, most of the consumers are not available to buy products made with wastewater in Europe, but they are buying freely from Israel, that we know that large part is produced with wastewater. So it's matter of create a positive narrative and don't scare the sector that in that case has to put money and to take risks.
Thank you very much, Adriano. Rafael wants to comment very, very quickly. Rafael, please.
After.
And
one thing that is very in parallel with what Rafael said before, because here I think that is a problem of timing. This take a lot of time. You are talking about a good narrative about the reuse, but this narrative is we're talking about it for 30 years. That's what appear people talking against the reuse and for the reuse. It's the same with the vaccine. The vaccination that you told before, Rafael. In Israel, during the vaccination took 2.5 months, and was very, very, very fast. And that's why it was not people against the vaccination. If you take a lot of time, like in other countries, it will appear like now in Israel, people that talk against the vaccination. Okay, so the narrative is very good, but I think they take a lot of time to talk or to tell about this narrative and to try to convince, and it appears. You have a very good story. The story is a very good story to tell, but the question that I don't think the media and everything else is against all this process, and I don't know if you agree with that, Rafael, but
quick reaction from Rafael.
My reaction to that is I tend not to complain about what the media or other people may do that I don't like. My attitude is to be proactive, not defensive. Proactive, clarifying the issues, and particularly dramatically improve our terminology. We are hopeless in many cases. We are still using wastewater. If you look at the bottles people have been showing you during these demonstrations, in many cases where you go, that's not wastewater anymore. That water is probably much better than any water that people are using from the river. Because the idea of a river is something pristine, blue, like we see in movies, going into the mountains.
Yeah, it's not like that. Yeah.
That's not the case. So we have to improve images. We have to improve and be consistent with terminology. Just call it reclaimed water, used water, purified water, whatever you want. As a matter of fact, we should be consistent with the regulation. Those keywords are already established in the regulation. So why people are still talking about tertiary treatment? What people say, what? But you see, even the regulation itself, in the first sentence, it says something like natural resources are under pressure. What do you mean pressure? What do you think people in the street are going to understand by pressure? Pressure, everybody understands. You put a weight by surface, this is pressure. Means pressure in that sentence means there is a disequilibrium. I mean, there is an imbalance between needs and availability. That should be said in the regulation. People otherwise don't understand. So again, terminology, good ideas, good images, and not be defensive.
So,
Always
good
indicate,
marketing.
congratulate the one that is performing well. If the others don't want to vaccinate, it's fine with me. We will provide them hospital facilities and wish for the best.
Okay, let me give the word to Despo. Despo, I know you have been working in the development of a SARS-CoV-2 surveillance system. How do you see the future of wastewater, considering its reuse potential and also the new possibilities like this? What's your experience? What can you extract from that, and also what can be applied to this debate that we are having?
Yeah, so I think it's very clear that treatment plants can be seen in the near future as not end-of-pipe treatment plants, but as recovery facilities, providing a great potential for resource recovery, not only water. So what is currently missing, I think, is not the technologies to do so. We have heard about recovery technologies also in the elevator pitch. But the absence of integrated strategies and relevant policies to drive the market. And for this to happen, we need a more intensive discussion among a broader range of sectors so that the recovered materials and products can become a part of the circular economy. Now, concerning the wastewater treatment plants as chemical or microbiological observatories, since you have referred to the recent huge effort by the Joint Research Center, the JRC, to forecast human and ecological and health risks, it is true that considering that the wastewater mirrors the consumption and the health conditions of the population that each plant serves, wastewater offers the ability to rapidly monitor the spread of diseases, something that is key for prevention, intervention, and control. So wastewater-based epidemiology or otherwise environmental surveillance is a new tool that has the potential to act as a complementary approach for ongoing infectious disease surveillance systems, and we do have a new recommendation coming from the European Commission that was published a month ago, I believe. So this recommendation now asks for the member states to establish wastewater surveillance systems by October the 26th. So this may give us the ability to use wastewater treatment plants as observatories. An ability like this could be used in various ways, as a preventing or early warning tool, as a management tool. For example, the absence of a pathogen in wastewater from a particular zone could indicate that the corresponding zone can be considered as of low risk at the time the sample was taken, or if a pathogen present is low and stable or in decrease, this could mean that the outbreak is under control and that measures taken are efficient. It can also be used as a safety net. If testing of the resident population, for example, is negative, but the pathogen is detected in wastewater, investigations of other infection sources should be initiated. Therefore, concluding, I can see and foresee a complete transformation for the wastewater treatment plants. It is obvious that there are indeed different ways of turning wastewater treatment plants into both resource recovery facilities and information observatories for the benefit of a greener and healthier future.
Thank you. Thank you very much, Despo. Well, I have a question from the audience here. Well, as you know, this is an international conference, so we have participants from all over the world, and we have one person from Brazil who is commenting on our previous discussion, the need to convince the positive narrative, and he's asking that we are talking about the challenges in Europe, Israel, in developed countries, but what about developing countries? What kind of messages, what kind of strategies we should use in this specific context? Any comment on this? Well, Diego, please.
Okay.
Yes, please.
Rafa, you are not so fast. You came after me all the time, raising the hand.
Diego,
you
you're
must
faster.
Be, faster. Yeah, faster. Okay, I raised the hand before you ask. No, we are working in other places in the world, and the same thing is to build trust is not only to reuse of effluent, is to planning all of the water sector, to make a master plan. Everything is built on trust. Also, economy is built on trust. So that doesn't depend if we are talking about Europe, developed country, or a developing country. Latin America, the lack of trust is huge. And I can see not only Brazil, Argentina, Peru, and there's a huge problem with the trust. And I think that the main thing in order to move forward, and again, it's not only to talk about the reuse of effluent, is to planning the water sector for the future. Okay, is to rebuild the trust and to start with, let's see, to be sincere, to understand that it's impossible to move forward without understanding what is our real situation. That is, all the things that we are doing until now are not so good. So we have to be sincere about everything and to move forward and trying to build the trust. And this is a thing that we can see in a lot of places. It's not, again, with reuse.
Thank you, Diego.
Please, Rafa, please.
Rafael, quick comment from your side to the audience.
Thank you. I just raised my hand, but probably because of communication, my finger appeared before others. But no, I was ready to go after you. So concerning those developing countries, my opinion is sanitation is the key point before we consider any other thing. Because the end point is the same. Health of the people by drinking water and by sources of water. So sanitation should be the main effort. As a consequence of sanitation and improving the water coming out of the wastewater treatment facilities, the environment will be protected. Indirect reuse will take place like it has been taking place all over the globe for years, and that is the immediate solution. How to conduct this sanitation? We have technological solutions, we have nature-based solutions, but we have to be very clear about nature-based solutions. Yesterday was mentioned by De La Cámara, they go slow, because in this planet we live, we are supposed to go slow. Our thermodynamics, our biology, everything goes slow. My nature-based solution to go to the market is walking. The most I can do is 5 kilometers an hour. If I want to go to Copenhagen, it may take me years to go. If we are able to, or we want to go faster, we need to use technological solutions. But so that would be my best recommendation, sanitation, and from there, progress. Concerning that idea of sanitation and the ideas that were raised before about talking about wastewater treatment plants, my recommendation, following this idea of images, when we talk about reclamation, we should not be talking about wastewater treatment facilities. We should not be talking about wastewater. We should be talking about treated effluent. This is just like if you are talking about, a farmer is talking about fertilizers, he's concerned about the quality of the fertilizer. He doesn't have anything to do with the way the producer of the fertilizer is doing it, other than assuring a good quality. So we should be distinguished with those two things. Of course, they are technically and scientifically interrelated, but if we start talking, bringing our visitors to a water reclamation facility and we start the visit in the effluent, when the wastewater comes from the sewer, we have no future. Of course, there is nothing to cover up. There's no need to cover up, but it's a question of education. We have to proceed in a rational way. That's my concern.
Thank you, Rafael. We need, sorry to interrupt, but we have very little time. I want just the last comment from Adriano. Adriano, 1 minute, and we will have to conclude because we are already out of time.
Very fast. I agree with Rafael, but let's say, and I also take the point of Despo. We need to talk about regeneration plants. They are new industries. What Andres was showing us, the HMAF, now there is a plant, an industrial plant made by Michelin and AVA, that is a big industry of biochemical product in Switzerland. There is an industrial plant to produce HMF. So regeneration plant and the reused, let's say, regenerated water must be like a product, an industrial product. We have to separate from the idea that is a natural resources, is engineered water that can be adapted for the use of the farmers. If they are receiving something that is engineered on their own needs, what they have to complain?
Thank you, Adriano, and thank you all for this vibrant and interesting discussion. It reminded me our project meetings. I can tell the audience that our meetings were like this. Were really interaction, carrying each other, discussions. It was
fighting,
really great.
Fighting all the time.
I'm fighting a lot. Yes. So it was a good memory. It's like if we were in a project meeting. Unfortunately, we don't have all the time we wished because we could be here for hours talking and talking. We have to move on. So just thank you, our panelists, for being here and provide such a brilliant comments and fascinating discussions. We have to move on. Rui, what do we have next? What's coming on?
Well, next we have a keynote presentation, but first of all, let me just say that we had such an inspiring roundtable. We were mentioning yesterday the stories of yesterday from Cyprus and Israel, but this was really, really, really inspiring.
Yeah.
And I'm feeling a bit sad because we are moving to the end of the conference. So, but even so, we still have two quite interesting keynote speakers. For now, we'll have Andrea Rubini from Water Europe. Andrea Rubini holds an MSc in Water Resources Engineering and has more than 30 years of international experience in the water and energy sector, in climate change and related impacts in urban and industrial areas and ecosystems. So he spent the last 20 years in the multi-level European lobbying context of Brussels, where he gained an outstanding knowledge of the EU research and innovation policies and funding programs. Andrea works at Water Europe, the European Technology Platform for Water in Brussels, as Director of Operations, and he is in charge of the market and collaboration programs. Represents Water Europe, the Water GPI, and the Aspire as member of partnership board. Andrea, thanks for joining us. Can you hear us? I hope so.
Yes, I can hear you. Thank you very much for the introduction.
No. Thank you. And the floor is yours. Welcome.
Thank you. Good afternoon, everybody. Thank you very much for this great opportunity. I've been following. The previous discussion. It was quite challenging and with a lot of inputs. And really food for thinking and developing new ideas. Now, I would like to introduce Water Europe as the voice and the promoter of the water-related innovation and research and development activities in Europe. Let's go with the first slide. Let me know if you can see. The second slide of the presentation. So, what is Water Europe? Water Europe is the voice, is a recognized voice of the promoter of the water-related research and development and innovation in Europe, with the mission of coordinating and supporting, the enhancement of the cooperation in the water ecosystem in the European Union and in beyond the European Union. We really want to support the water sector to be more performant, more competitive in Europe and beyond, and to contribute to solving the global water challenges through research and innovation. We have a strategy because Water Europe it's a multi-stakeholder association that represents the whole water value chain, and including, we have 7 colleges where we host, 7 different categories of water stakeholders, starting from the multinational corporation in the water in the college A, passing through the research and technology providers like universities, research centers. Then we have utilities, the suppliers of technologies, large water users, and then we have other 2 colleges that collect, the public authorities and the civil society organization. Water Europe produces, a water vision that is called the value of water, and is an emblematic identification of what is within water. Its value, that is not its cost, but it's really what we can do in our society for the well-being of the citizens and the well-being and the capacity of the economy to be competitive and up to the point. It's a value-based organization, and we support the activities of the Living Labs as a place where water challenges can be more easily addressed. I mentioned the water vision because we have a number of challenges. You already know these challenges. We have, a problem of scarcity of water. We have, a big challenge concerning the pollution of the environment that includes water, and of course we have, the consequence and the impact of the climate change. So we advocate, we support, we want to achieve what is called the water smart society, where the true value of water is recognized and is realized. We want to support whatever is needed in order to reduce the challenge of the water scarcity and the pollution of the water resources. We want to work in order to foster, to promote a circular economy within the water smart society, and create a water system that is resilient against the impact of climate change and other crises, as the COVID-19 already shown us, as a possible additional challenge. You can see from the infographic on the right that for this value of water, for achieving a water smart society, we need technologies for sure. We need to rethink our system of infrastructures through a system that includes hybrid gray and green infrastructures, and we need, excellent, efficient, well-working governance in order to have, this systemic approach in achieving the value of water and a water smart society with the inclusion of all stakeholders, including the citizens. I've been listening to previously to the debate about the reclaimed water, and I might also suggest that in our vision, in the Water Europe vision, we have a number of innovation areas. But what we point at it is that we don't have only one water. We have a number of different waters that can be used for different purposes, for different products, for different stakeholders. And you see, the industry, agriculture, homes, the service, and the recreation and the nature itself are in the need of having waters that are not necessarily the one water to which we think, and that it could be the fresh traditional water, but could be water coming from a previous process that can be used by other users as it is, or with a minimum level of treatment. Water Europe has 3 main programs. We have the advocacy program that it is emblematic, and it is made in order to make sure that the value of water for the society is reflected in the European policy and the funding programs as well, because research innovation needs adequate policy and needs funding programs that are can support them in the development of new solutions. We have a collaboration program that's where we allow our members, to exchange, to collaborate across the water value chain in order to address water challenges and create consortia for new projects. And the market program in order to foster or to build or to contribute to the building of the bridge in this value that between research, innovation, and the market uptake. These are, a quick view of the board members of Water Europe. Water Europe has also this advocacy program that is quite important because we want really, to support, a policy making that can really facilitate the achievement of a water smart society. The collaboration program is made by a three-dimensional collaboration matrix that is made by working groups and by the vision leadership teams that are two main groups of level organizations within Water Europe. We have, a water vision leadership teams that is organized in horizontal think tanks that are research-oriented, and three vertical think tanks that are limit lab and market-oriented. And of course, the three ones, are focused on the challenges about the industry, the cities, and the rural environments. Then we have working groups. We have 20 working groups. Here you can see the leaders of our working groups. Our groups are the backbones of Water Europe concerning research and innovation development. So now a few considerations about water. And you might find strange that I start from one of the three environments that I mentioned before, that is not rural, it's not urban. We'll see later. But we should think about the matter that water is a local resource, is a local challenge. It is not endless, and it's a shared resource. So, we have these three criteria, we have these three factors that are very important to consider whenever we go for considering a system that can help us, to use in a more efficient way water. The point is that so far we do not have, a clear sustainability endpoint for water utilization. Now, I start from the industrial context. You say, why the industrial context? There is, some issues that are quite important. We'll see in the next slide. In Europe, around 54% of the total water is abstracted in the European countries, used for the combination between energy production and industry, which is very high if you compare, to the 19-20% that is, the average at global level. So these things, should also make us think that there is an enormous potential capacity from the industrial sector to be important in the challenge of making water circular in the view of a water smart society. At the same time, water is a job enabler. 78% of the jobs at global level are depending on water. And there is, a very strong correlation between the water-related investment and the national income, and between the water storage capacity and the economic growth. So you can see, how these factors goes hand in hand at global level, not only Europe. Now, there are key opportunities. Given for granted that there are key opportunities between the urban and the rural areas, and we've been, I've seen that this has been discussed before, but there is also an important area where we should consider, that is the interaction between the industrial areas, the rural and the urban. If you look at the rural areas, the industry and the rural environments can really collaborate in a circular way by exchanging, because the rural sector can provide, can support the supply chain for the industrial sector, and the industrial sector can provide water for the irrigation and nutrients. But at the same time, we have a number of challenges because it is now recognized that water represents a risk, an economic risk, a societal risk for our society, for the industry, and in the consideration that time by time we have been using these not endless resources in a way that led us, to have in the freshwater species declined by 83% from the 70s. While we are almost what is left of the wetlands in Europe, it is just less than 30% of what we had since the beginning of the past century. So there is the need for taking action because despite the efforts that have been taken up to now, what we have seen is that the water-related impacts on our society, communities, the ecosystems, and the economy are just on the rise. So, as already mentioned before, there are a number of areas that we should explore in order to foster the value of water and provide the confidence of investors to invest, because there are a number of disconnection between the business operators and operations in the water sector. Because one is how the water challenge is perceived by the operators, how also the corporate water goals are perceived and understood, and what is about the understanding also of the capital investment that is necessary in order to keep our growth sustainable, and at the same time use water in the best way and in a different way that is not any longer this linear mode, take, use and dispose, but enter into the full circularity. So there is we have a number of problems because, as we can see, there is a lack of a transparent process really for understanding what is the sustainable utilization of water and how we can really have this high level commitment and investment in order to secure that our future society will be water secure. And really, we need to work now, and it's a business imperative to take solution, to find solutions for the water challenges. And what has been suggested by several parties that what we can use in terms of indicator is what we are being neglecting more, the biodiversity of our system. So the more the biodiversity improves, the better will be the environment. And if we do this in a circular way, considering that business must also change from any sector, using the biodiversity indicator can help us understand if we are on the right way. We need to change direction. Whether Europe provided a document, developed a document called the SIRA, that is Strategic Innovation Research Agenda, and in order to support new technologies, new systems, new models for financing, new business models, and new partnerships. And at the basis, we need really to understand how to quantify the supply and the demand of water, how we can develop methodologies in order to understand what is, a fair allocation of water to specific stakeholders, and this is in a systemic approach and in a circular approach, and this will really allow the full deployment of the real value, the true value of water. So there are a lot of opportunities in this symbiosis approach into new solutions that can put together the urban and the rural and industrial sectors. As I said before, one of the main points that we see as a barrier is that we are still locked in this linear model that is take, make, consume, and dispose. That of course doesn't work in a circular approach, but we really need new solutions and new investment in order to have this new system taking off. There is the need also to consider that as water is a local issue, local solutions are also needed to be developed and deployed. In a nutshell, concerning this talks about how we can achieve a water smart society and the circular water. We need to really secure a long-term resilience, stability, and sustainability of industrial and other waters, and we need an holistic water strategy that takes into account all the sectors and put together in a concept of water smart society. Living labs can be developed, promoted, supported in order to allow an easier transition between the research, the innovation, and the market uptake of new solutions. And then, we need really to promote new systems in order to support business strategies for the utilization of the water. This is just an example about the importance that Water Europe gives to the water-oriented living labs. We published an atlas of the water-oriented living labs that also provides a criteria for the classification of the living labs in Europe. This document is will be under review starting from this year. Water Europe participates also in a number of H2020 projects, in where most of them, are focused on circularity and water smart society. I'd like also to announce that next month we're going to have our flagship event, Water Innovation Europe 2021. The title is in EU Water Smart Society for Global Leadership. The registration are open. You're welcome to participate, and it will last for 1 week. We are going to have 5 sessions and 8 side events, and these are towards what will be the European Water Smart Society for a global leadership. These are our key publications. We have the Water Vision, the CIRA, the Water and Living Labs, the reports on the overview of Water Europe member union projects. And we have also our late contribution to the Green Deal as in Europe publication. Last but not least, it's invite. Join us, or stay with us. As long as you wish. It will be an opportunity for build together a water smart society. To expand your networking, to develop your business, and why not also to have fun and to find, also peers with whom you can exchange and grow your expertise and get recognition. That's all. Thank you very much. I'm available for any question, and I pass the floor to Antonia.
Thank you so much, Andrea. Perhaps we'll leave the questions after Antonia's presentation. Antonia Lorenzo. Antonia has a Bachelor of Agricultural Chemistry and specialist in Environmental Engineering and Technology. Hi, Lorenzo. And she is a founding partner and head of R&D at Bioazul from 2004, with more than 20 years of work in the management of international projects. You are also an expert in the European Commission framework programs, including the H2020, of course, as well as in the preparation and management of international projects, mainly related to treatment, management, and reuse of water, ecological, sanitation, waste management, circular economy, sustainability of resources, and other environmental issues. So I guess you are in the right place, Antonia. I'll just give you the floor, Antonia.
Yeah.
Thank you so much.
Thank you, Rui. Can you hear me well?
Perfectly.
Yeah, good.
And let's see the presentation.
Okay, good. And I will. Okay. So thank you for the invitation. It seems I am the last one in this Suwanu Europe conference. It is a pleasure to be here today. I would like also to congratulate you all for the organization. It has been great. And then I will explain a little bit now about the Water and Agri-Food working group, which is one of the working group of Water Europe, as indicated by
Andrea? Yes, I can do it. Okay, good. So the working group is led by me with the support of Rafael, who is somewhere there today, and also co-led by Alfieri Polite from IRSA CNR from Italy. It is based, let's say, in pillars and the work we do within the working group. We focus on the good practices and innovative solutions to improve the sustainability of the use of water resources in agriculture, food processing industry as well. We consider several approaches like minimizing the water that is being consumed, water reuse, so use of reclaimed water, and also desalination, so recovery of also from wastewater. So we consider different approaches in order to move to these sustainable solutions. And another is the multi-sectorial vision. We understand that we need to involve all like water sector, food industry, and agriculture sector to promote these synergies and to boost the cooperation. In Water Europe, we have mainly members which are belonging to the water sector. This is moving, changing. This is why we need to understand better the challenges, the demands from the industry and the agriculture sector to develop solutions for them. The working group now by around 60 members, different kind of entities which are members of Water Europe. And we have recently created a core group for every working group within Water Europe. And in our case, we have a core group formed by experts belonging to different kind of entities, universities, companies, research center from different countries, as you can see here. And they will work with us, with me, with Rafael, with Alfieri, during this next period, let's say from June on organizing and implementing the working group activities. The working groups are more operational bodies, as also Andrea explained in his presentation. Research and development and innovation and business driven, let's say. So we promote all these kind of activities as you will see now. Sorry, So we have three main objectives in our working group. One is to increase the interaction and this exchange of knowledge between members and enhance cooperation in research, development and innovation activities, for example, through the building of a research project together, but also at commercial and business level by, let's say, cooperating in different contracts or with industry, so direct contact with industry. So in order to promote and to increase this interaction, we organize 3 meetings at least every year, normally alongside the Water Europe events. Andrea was mentioning the one that is coming in June, but normally we have 3, Water Innovation Europe, Water Knowledge and Water Markets Europe. So we always organize a working group meeting during these events. Next one will be the 24th of June. During these meetings and all the meetings that we do online, we discuss all the activities and the work being done, the demands, the barriers, or different kind of aspects related to water and agri-food. Within each meeting, we also have a specific time for the members to present their activities to the other members, what we call no to working group members, because we are a big community and not always is easy to communicate. So we use the meetings also to promote this dissemination of activities and the cooperation in between the members. The second objective is the identification of the agri-food water-related challenges and increase the interaction with the food agriculture-related activities. This is also something that we, as already mentioned, we mainly have water members from the water sector. So we need to increase this interaction and exchange of knowledge with the agri-food sector. That's why we organize workshops with the relevant actors and we are always open to hear from them the demands in order to develop solutions for the more sustainable use of water in the agri-food. We have to understand, it was also mentioned in these days, that the agri-food sector is consuming around 70% as an average of the water that is being extracted worldwide. And in some countries it's even 80. So whatever solution we implement for the more sustainable use of the water, the impact will be very high. And this is what we are looking for. The last objective is the dissemination of the activities we are promoting within the working group, as the activity we are doing today. And also we promote the interaction internally in Water Europe, because there are many vision leadership teams, there are many working groups. So also we promote in our meetings this interaction in between other working groups that could cooperate with us in our activities. So this is just an example I wanted to give you on one of the activities we performed by the end of 2019. We have performed others, but this is the last one that was face-to-face, and I'm missing a lot these kind of activities. So this was a workshop we organized within the EIP Water event that took place in Zaragoza in December 2019. And we did this event together with Suwanu Euro project and also with this EID Food initiative, which is promoting also a project on water scarcity in which we are involved as Bioazul. And we are already in the second year of this initiative. So we organized this event together as in order to reach the water sector, but also the agri-food sector. It was a side event of this conference, as I said. So for this year, normally we work in a period that starts in June every year and finalizes in May. So we are almost at the end of this 2020-2021 period. And for this, we are forcing to carry out different activities. The ones I mentioned are normally in line with all you can see here in the chronogram. But I would like to mention also to point out that we are within the working group preparing a white paper on the new regulation, the EC regulation 2020-741 on the minimum requirements of water reuse in agriculture. So we want to identify within our working group and in cooperation with other working groups within Water Europe the barriers and the opportunities of this new regulation in its implementation, and also how it can affect, or it could be the base for other future regulation for industrial reuse, for example, or urban reuse. The white paper is now in the oven. It will be ready hopefully by June. We are willing to present it within our meeting the 24th of June. This is more or less what I wanted to say. So if you are not part of Water Europe, you can join. Once you are there, you can also join our working group and work with us together in this very relevant aspect of water and agri-food. And if you are not member of Water Europe, but you are interested in cooperating with the working group, you can also contact me or Rafael. This is all I wanted to say, Rui. Thank you.
Antonia, thank you so much. Perhaps we have here one or two questions from the QA, and I will ask you directly because you're just mentioning. Someone is asking here two questions: is how can we join? How can our organization join your initiative? And also, how can we be engaged in this group? And also the profile of the working group. What is the profile of the working group? So you have do you have, for instance, farmer organizations represented? Do you have researchers? It's more industry?
Okay.
Yeah?
Yeah.
So how to be engaged in your group, and what is the profile of the working group nowadays?
Okay, we try to answer both. First, in order to be in the working group, you have to be a member of the Water Europe. It doesn't mean that we cannot make activities together. because we do with external members or external partners. We do some activities, but in order to be in group, you have to be a member. But in any case, if any of the audience is interested in the activities we are performing, they can contact me or Rafa, and then we can see how we can organize any kind of cooperation. Regarding the profile of the members of the group, there are many research centers. There are universities also from all around Europe and other associated countries as well. We have also quite a lot of SMEs delivering innovative solutions for the industry and for agriculture. So we have also let's say technology developers, but we also have service providers within our working group. We have some industry as well, but it's not the main profile. And we are willing to have more and more farmers and industrial partners from the food sector. Mm-hmm. And this is still something we are working on. That's why we are trying to do this kind of interaction in between members and non-members, trying to identify relevant associations or key players in the agri-food sector in order to reach them and try to involve them. Maybe not being Water Europe partner, but giving us the feedback or the information we need in order to develop tailor-made solutions for them.
Okay, Antonia. I guess you will have a lot of requests. I guess I will speak directly with Rafa, so I won't need to send an email. Andrea, we have here a question. It's about the atlas of the water living labs. Someone is asking, what are these living labs? If you could explain a bit more, and if this atlas is available and is supposed to be updated quite often.
Well, I mean, what is a living lab? Thank you very much for this question. It's important. Well, a living lab, I mean, it's a place where, ideally, I mean, all the stakeholders that have, I mean, in their program, as an objective, I mean, the sustainability of the local society are on board of a system that is able to manage resources, the economy, the needs of the society, and I mean, towards one common strategic objective. Now, the water-oriented living labs are living labs where water represents an important factor, or the leading factor, or the main factor of the sustainability of that territory. Once again, I mean, let's point to the fact that water is a local challenge, is a local issue, and requires, local solutions that can be replicated. In a living lab, you can really, it's easier, to have, all on board. When I say all on board, it means that we identifies, the needs for research and innovation, who supports, the investment in research and innovation, who provide the governance of the systems, and the system itself is able, to test, the new solution, the new innovations, and can facilitate the market uptake of the solution. The Water-Oriented Living Lab Atlas, it's available on our website. You can download it, at any point of time. And it's a living document itself, because living labs are living entities. And Water Europe, Water-Oriented Living Labs is advancing and will progress in the next months and years. And the document will be updated as well, because it requires attention, in order that we can really pick up the new living labs that are water-oriented and can be entered into the document, and to update also the existing ones. What is important also that this document provides an exact, well-defined system for the categorization and identification of the water-oriented living labs.
That's perfect. So living lab and is a living document. It makes all sense. I'm sorry, but we have to close as soon as possible. Antonia, I hope to see you soon, face to face again.
I really hope so. I'm very sad that we couldn't make it together, this final conference. But I got congratulate for the work being done for the
It will happen.
organization.
It will happen. Yeah.
We will have other opportunities.
Yeah, for sure. And Andrea, good luck for your water innovation event next month. I hope it goes
Thank you very
well
much.
with
Thank
all
you
of
very much.
success that you guys deserve.
Yeah, and you're all invited to participate. A registration is open, and you're really welcome to register.
We will. It's a promise. Thank you so much. And now the session that I really don't like, that is the closure session.
Yeah.
Rafa?
Unfortunately, it's time to conclude. We had today a very constant audience. It means you find this conference interesting and useful. I'm happy for that. Well, for us, it has been a pleasure to have this extraordinary conference. If there is something I have learned in these 2 intensive days, is that that we need to hear all voices. We had a very interesting discussion in the roundtable with different approaches, but we need to hear all of them, all of these voices, to find best solutions to cope with water scarcities and to solve the challenges of the water sector, which are very complex. Water reuse can be easily achieved from a technical point of view, but because there is plenty availability of treatment plants, membranes, filters or pumps, but water reuse requires many more elements to be considered. It's really a complex issue. We need to consider governance, cost-benefit aspects, social perception or the effects in the agronomies. We also need to communicate better. This is very relevant, not only by using sound and evidence-based information. We also need to emphasize the benefits of using reclaimed water. We need to post positive messages. We need to use a positive narrative. In Suwanu Europe, I think we try to contribute to these challenges in the best way, collecting the most relevant results of research and innovation, success stories, and present them in an accessible way. That was our goal. We have made available a good bunch of materials, I think, and they are all in our website. And we have a complete e-learning course adapted to different target groups. So I hope you find these results useful. It can be a game changer for the future of the water sector. Thank you all for being with us. And thank you for the brilliant speakers, the panelists that we had today. Well, Angela, we are about to finish.
Yeah, it's a pity, but it has been a pleasure hosting this event together with you both, guys. I feel very happy about the result achieved after all the effort made during this month, because it's a work of months. And I want to thank all the consulae team, especially, Rui, thank you to be here to us, but especially to Marta Mendes and Carolina Ramos for the great work in the collaboration with us and all these organization issues. That is amazing. Be here, stay in an international conference with you in your TV or in your computer is amazing. So, and also I want to thank you, my colleague, David Salaverry from Bioazul. He is not here, and it's a pity because he makes a great effort and a great work in the dissemination of the event to achieve that you be there with us. Well, now we have arrived to the end of the conference, but we will continue to disseminate our results because we have great results to show you, because we would like to share and transfer knowledge across Europe. We like to create a real community on water reuse. Who knows, maybe we have the opportunity to work with you in a new project, in a new initiative on water reuse. So please follow us in our social media, Twitter, LinkedIn, Facebook, YouTube, and Facebook. Write us your ideas, your comment, and stay in touch, subscribing to our mailing list at Suwanu Euro website. Thank you very much.
Angela, just final words. I guess you said everything, you and Rafa. But once again, we'd like to thank the keynote speakers, the partners of the excellent presentations and discussions that completed this day. I think it was great. We also like to thank to all of you participants who stayed online through these 2 entire mornings. It was great, and to promote these very interesting and challenging QA sessions. We have a lot of questions that will be answered for sure. Although it was impossible to hold this conference in a face-to-face format, we managed to get an average, again, of more than 200 attendees, which is great, and almost 500 registrations, which is very important. Thank you all. I would like also special thanks. Thank you, Angela, for the congratulations of Consulize team. Also extends to the professionals that they are behind the scenes. You don't see them, but they were quite good also. And this is quite complex process, and they were super. Yes, and we are available for comments, suggestions, questions related to the project. So do not hesitate to contact us through the project communication channels, Consulize or Bioazul. It's the same. Once again, follow us, and thank you all from Portugal, where the headquarters of this international conference has been located. See you soon, and don't forget that every drop counts in our project.
Yeah, it's true. Thank you.
It is.
Thank you so much.
Thanks a lot.
Bye.
Bye-bye.